Imagine this. You are lying down in a quiet room. The lights are dim and the world outside has grown silent. The day has ended, but your mind remains awake, wandering into questions bigger than life itself. Questions that have echoed across centuries, whispered in temples, pondered under starlit skies, and debated in universities. Questions that stir both fear and wonder. And perhaps the greatest of them all is this: are we truly alone in the universe? This question is not just scientific, it is profoundly human. It lives in our poetry, our myths, our religions, and our science fiction. It appears in the child who looks up at the night sky and asks if anyone else is out there. It echoes in the astronomer who spends years pointing a telescope toward a star, hoping for a faint signal. It lingers in the philosopher who wonders whether life has a universal meaning, or whether our small world is all that exists in a sea of silence. And tonight, or today, whenever you are listening, you and I will embark on a journey together. A journey that stretches across billions of years, that spans unimaginable distances, and that asks us to face the most profound possibilities of existence. What if the universe is silent and humanity is the only intelligence it has ever produced? What if, in all those galaxies and stars, no one is watching back? And what if we are not alone, and the universe is filled with civilizations far older, far wiser, perhaps so advanced we cannot even comprehend them? This is the cosmic question. And for the next 3 hours, you will live inside it. Why this question matters. Some questions are small, practical, and temporary. Others are eternal. The question of cosmic loneliness is one of those eternal questions, shapes how we see ourselves, how we value our existence, and how we understand the story of life itself. Think about it. If we are the only intelligent beings, then every song we sing, every book we write, every discovery we make, these are not just human accomplishments. They are the only such accomplishments in the entire cosmos. They are unique, fragile, irreplaceable. Humanity would then bear a responsibility unlike any other to keep the flame of consciousness alive. Because without us, the universe might remain forever unconscious of itself. But if we are not alone, then the universe takes on a different character. It is not an empty desert, but a crowded city. Somewhere, across the stars, minds have bloomed, societies have risen, technologies have evolved. Perhaps they have faced the same fears and questions we do. Perhaps they have surpassed them. To know that others exist would change our place in the story of existence. We would no longer be the lone voice in the dark, but one part of a vast cosmic choir. Either way, alone or not alone, the answer carries unimaginable weight. And that is why we must ask it. A thought experiment: what if? Let's pause and imagine 2 parallel universes. In the first universe, we discover, after centuries of searching, that we are alone. No signals come from the stars. No telescopes find alien cities. No probes find alien artifacts. The silence is permanent. At first, this may feel terrifying, even depressing. But think about it again. It would also mean that life on Earth is the rarest miracle in all of creation. That you are part of something utterly unique, the only spark of consciousness the cosmos has ever managed to produce. In that universe, every human being becomes infinitely precious. Now imagine the second universe. In this one, we discover we are not alone. Maybe it begins with a faint radio signal from a distant star, unmistakably artificial. Or perhaps one day we detect a structure orbiting a sun, something so large and complex that nature could not have built it. Suddenly, we are no longer the only storytellers. Another intelligence has written its own chapters in the cosmic book. What would we learn from them? Would we fear them? Would we celebrate them? Would we even be able to understand them? Both universes are filled with awe. Both are filled with challenge. And both are worth exploring in our minds. Humanity's brief moment in time to understand this question. We must place ourselves in perspective. The universe is nearly 14 billion years old. Earth itself is around 4.5 billion years old. For most of that time, there were no humans, no minds capable of asking these questions. Life existed, yes, plants, microbes, animals. But the capacity to look up at the night sky and wonder, that is incredibly new. Our species, Homo sapiens, has existed for about 200,000 years. That may sound like a long time, but compared to cosmic history, it is almost nothing. If the history of the universe were compressed into a single year, with the Big Bang happening on January 1st, then human civilization, our entire history, would appear in the last few minutes of December 31st. Think about that for a moment. The universe has been waiting billions of years before we appeared and began asking questions. We are new, fragile, temporary, yet perhaps also the beginning of something far greater. And so the cosmic question is not only about the stars. It is about us, about how we see our role in a universe that has existed long before us and may continue long after us. The weight of wonder. When you stand under a starry sky, it's easy to feel small. The stars stretch endlessly, galaxies swirl in unimaginable numbers, and Earth feels like a tiny grain of dust. But in that smallness, there is also something profound. We are the ones who notice. We are the universe becoming aware of itself. This is the paradox of the cosmic question. On one hand, we may be insignificant compared to the vastness of space. On the other, we may be the only beings who can give that vastness meaning. Alone or not, our existence changes the universe from being a silent, conscious expanse into something alive with thought and reflection. Long before telescopes, long before science, human beings stood under the same sky we see today. The ancient Babylonians mapped the stars into patterns. The Egyptians aligned their pyramids with celestial points. The Greeks and Romans wove stories of gods and heroes into constellations. Every culture, across every age, has looked upward and wondered. For them, the question was not framed as "Are we alone?" but rather, who else is out there? Gods, spirits, ancestors, watchers, they filled the sky with presence. The stars were seen as eyes, or as homes of divine beings. The heavens were not silent. They were alive with meaning. Only in the last few centuries have we shifted toward the idea that the cosmos might be empty. With the rise of astronomy, we discovered the vastness of space and the apparent silence of the stars. This silence felt eerie. After all, if the universe is so big, shouldn't it be teeming with life? Shouldn't the night sky be filled with signs of activity, with lights and movements, with voices from afar? And yet, night after night, decade after decade, the silence remains. The silence that speaks there is a strange tension in this silence. On one hand, it comforts us there are no obvious cosmic threats, no signs of invasion, no overwhelming alien presence. We are safe in our quiet corner of the galaxy. On the other hand, the silence is haunting. With billions of stars and trillions of planets, the absence of contact begins to feel like a mystery in itself. This is sometimes called the Great Silence. A universe so vast, so old, so full of possibility, and yet so empty of evidence. Why is the silence hiding a deeper truth that we are alone? Or does it mean that life is out there, but distant, cautious, or so unlike us that we cannot even recognize it? Silence can be terrifying, but it can also be profound. In the silence, we are left to imagine, to ask what if, to project our hopes and fears into the void. The fragility of perspective. Consider how recent our own awareness is. A few hundred years ago, we believed Earth was the center of the universe. The stars were thought to be small lights just above us, hung on a crystal sphere. Then, through the work of Copernicus, Galileo, and countless astronomers after them, we learned that Earth is not the center. We orbit the sun, and the Sun is just one star among hundreds of billions in the Milky Way, which itself is one among trillions of galaxies. This shift shattered our sense of centrality, but expanded our sense of possibility. If Earth is not unique as a planet, perhaps life is not unique either. If stars are everywhere, perhaps civilizations are everywhere too. But with this realization also comes humility. For the vast majority of cosmic history, there was no human voice to ask these questions. For the vast majority of space, there may be no one listening. The emotional dimension, this is not just a scientific puzzle. It is also an emotional one. Loneliness is a deeply human feeling, and when we project it onto the cosmos, it becomes something vast, almost unbearable. To be alone on a personal level is painful. To be alone as a species in the entire universe is almost beyond comprehension, and yet some find comfort in it. If we are alone, then our story is truly ours. There are no competitors, no higher civilizations overshadowing us. Humanity's potential is unbounded, because there is no one else to limit or judge it. The cosmic question, then, does not simply ask about the existence of others. It also asks us to confront our own fears and hopes. Do we fear insignificance, or do we fear responsibility? Do we hope for companionship, or do we hope for uniqueness? Each possible answer reflects something about ourselves, looking inward. Looking outward. In seeking others, we also learn about ourselves. The search for extraterrestrial life is as much about identity as it is about discovery. Every time we send a probe into space, every time we scan the skies for signals, we are expressing something deeply human, the desire not to be alone, and the courage to face the truth if we are. Some say the universe is indifferent, that it does not care whether we exist or not. And perhaps that is true. But we care, and in that caring lies the beauty of the question. We may be small, we may be fragile, but we dare to ask. And, in asking, we transform the silence into something alive with wonder. Pause before the journey, as we continue deeper into this 3-hour exploration. Let us pause here at the threshold of the cosmic question. Close your eyes for a moment and picture the night sky. Imagine the stars spread across the darkness like a vast ocean of light. Somewhere out there, maybe another being is also looking up, asking the same question. Or maybe not, and the stars shine only for us. Either way is the question that will guide our journey. What if we are alone, and what if we are not? And so, we step forward into the vast unknown. From the earliest myths, humanity has struggled with the feeling of isolation. In many traditions, creation stories begin with a void, emptiness, silence. Darkness before life is spoken or shaped into being. This void is not so different from the cosmic silence we face today. For example, in ancient Mesopotamia, the gods brought order to a chaotic sea, fashioning a world where life could exist. In Greek myth, the cosmos was born out of chaos, the primordial nothingness. Even in modern science, the Big Bang is a kind of creation from emptiness, an explosion of energy and potential from a single point. These stories remind us that loneliness has always been part of the human imagination. We have always wondered whether the universe is barren or filled with presence. And we have always searched for ways to fill the silence with gods, with spirits, with aliens, with meaning. The cosmic question, then, is not just about discovery, it is about narrative. How we answer it shapes the story we tell about ourselves, alone as caretakers. Let us imagine, just for a moment, that the answer is clear. We are alone. Not just in our galaxy, but in the entire observable universe. No other civilizations have ever existed. No other beings have ever looked up at the stars in that scenario. Humanity is not just a species, it's the only witness to existence. Every sunset, every galaxy, every planet, every atom, would pass through the ages unobserved, if not for us. The universe, vast and magnificent, would be blind without our eyes, silent without our words, meaningless without our thoughts. What a burden this would be. But what an honor, too. If life is so rare, then we carry a responsibility to nurture it, to protect it, to spread it. We would not just be people living on a small planet. We would be the caretakers of the only consciousness the universe has ever known. This vision is both terrifying and inspiring. It asks us to grow beyond our divisions, beyond our conflicts. To see ourselves as guardians of something larger than nations or cultures. The fragile flame of awareness, not alone, but not the same. Now, turn to the other possibility. Imagine that we are not alone. Imagine civilizations that rose long before us, building wonders, exploring the stars, maybe even transcending the material forms we know. Imagine that somewhere, perhaps thousands of light years away, minds exist that are older than our planet. Minds that have thought thoughts we cannot even begin to understand. Would that make us smaller, war? Would it make us greater? To find that we are not alone would be to step into a larger community. To realize that intelligence is not Earth's exclusive story. It would expand our imagination, show us possibilities for survival, for technology, for meaning. But it might also humble us. We would no longer be the center, not even of our own narrative. We would be one voice among many, one civilization among countless others. Perhaps that is the truth the silence is hiding, that the universe is full of life, but so varied, so strange, so advanced that we cannot recognize it. Perhaps we are like ants trying to understand a library too small, too limited, too young to grasp what surrounds us, the human moment. Whether alone or not. Here is one truth that remains. Humanity's existence is astonishing. Out of dust and chaos, out of fire and stone, a species arose that can ask this question, that can dream, imagine, wonder. Pause for a moment and think about yourself. You are a human being living at the edge of the universe's story. You are listening to these words, thinking these thoughts, aware of your own existence. You are not just part of life on Earth. You are part of the only known consciousness in the cosmos. That fact alone is worth marveling at. We may never know the full answer to the cosmic question. We may search for centuries, sending probes and signals into the void, and still the silence may continue. But even the act of searching changes us. It stretches our imagination. It deepens our humility. It reminds us that we are part of something vast and beautiful, a gentle transition. So, here we are at the end of our first step in this journey. We have placed the question before us, looked at it from both sides, felt its weight and its wonder. In the next part, we will expand outward. We will leave Earth behind and look at the sheer scale of the universe, the galaxies, the stars, the planets. We will see just how vast the stage is on which this question plays out. But before we go, let us sit for a moment in stillness. Imagine the silence of space, the quiet hum of stars burning billions of miles away, the emptiness between them. Into that silence, we send our thoughts, our voices, our questions, and the universe waits. As it always has. What if we are alone? What if we are not? Either way, the journey has only just begun. Asterisk the illusion of smallness when we step outside at night and look up. The stars appear like tiny sparks scattered across a black canvas. They look fragile, almost within reach, like glitter dust thrown into the sky. Yet this is an illusion born of distance. Those points of light are not small at all. They are enormous furnaces, each one hundreds of thousands, even millions of times larger than Earth. What seems like fragility is actually unimaginable power to understand. The scale of the universe. We must begin with this simple truth. Our senses are not built for it. Human eyes, human lifespans, human measurements, these were shaped on Earth. For Earth, a tree, a mountain, a horizon that is the scale our bodies know. But the cosmos exists on scales that break our intuition. Distances stretch beyond comprehension. Time itself unfolds in billions of years. The first challenge of this journey is to let go of the comfort of small and large. In cosmic terms, both lose their meaning. Our cosmic address astronomers sometimes describe humanity's place with a kind of cosmic address. Imagine you are writing a letter to yourself. But instead of your street and city, you must list your place in the universe. You would begin Earth, the third planet from the Sun. Then the solar system. A family of 8 planets, countless moons, comets, and asteroids bound by the Sun's gravity. Next, the Milky Way galaxy, a spiral system of about 400 billion stars. And beyond that, the local group, a neighborhood of about 80 galaxies, including Andromeda, our nearest large companion. Further still, the Virgo supercluster, a sprawling structure containing thousands of galaxies. And finally, the observable universe, the cosmic horizon we can see, stretching 46 billion light-years in every direction. This is our address. From Earth to universe, each line expands the scale by orders of magnitude. Each one dwarfing the last, the journey begins. From Earth to moonlit, us take a mental journey outward, step by step. To feel the scale more directly, start with Earth itself, a sphere about 12,742 kilometers across. To us, it feels enormous. To drive across a single continent can take days. To fly across the planet can take many hours. Earth is, for us, the definition of vast. Now, look upward. The Moon orbits at a distance of about 384,000 kilometers. It takes light just over a second to travel that distance. Apollo astronauts took 3 days to make the trip. Imagine Earth as a marble, then the Moon would be another marble, sitting about 30 centimeters away. Space, even here in our own backyard, is already full of emptiness, Earth and Sun. The Sun, our star, the great source of all energy and life. It sits 150 million kilometers away. Light, moving at 300,000 kilometers per second, takes about 8 minutes to make that journey. If Earth were a marble again, the Sun would be a huge ball more than 100 times wider, and it would sit about 30 meters away. Between the two, almost nothing. Just emptiness, scattered with dust and tiny bodies. Already we are beginning to sense a theme. The cosmos is mostly void, with pockets of matter shining in the dark. The solar system's vastness lets keep traveling outward, past Mars at about 228 million kilometers. Then the asteroid belt, then Jupiter. 500 million kilometers from the Sun. Jupiter itself is massive, so large you could fit 1,300 Earths inside it. Its storms rage for centuries. Its moons form miniature worlds of their own. Saturn follows with its breathtaking rings. Uranus, tipped on its side like a rolling marble. Neptune, deep blue and windswept, far from the Sun's warmth. Beyond them, dwarf planets like Pluto wander in icy orbits. And still, this is just the inner courtyard of the Sun's domain. The edge of the solar system, the boundary where the Sun's gravity begins to fade, this the Oort cloud. A shell of icy bodies stretching nearly 2 light-years away. To cross it would take tens of thousands of years with today's fastest spacecraft. Pause here for a moment. Think about this. Our species has traveled no farther than the Moon. Robots have gone as far as Pluto, and only a few spacecraft Voyager 1 and 2 have crossed into interstellar space. Out of all this vastness, humanity's footsteps are barely visible. Like a single grain of sand on an endless beach, stars as islands now imagine leaving the solar system entirely. Beyond the Oort cloud, we enter the interstellar medium, the thin soup of dust and gas that lies between the stars. The nearest star to us, Proxima Centauri, is about 4.24 light-years away. In kilometers, that is about 40 trillion. Even traveling at the speed of our fastest probes, it would take tens of thousands of years to reach dot. Think of stars as islands in a vast ocean. Each one has its own system of planets, moons, and mysteries. But the ocean between them is so vast, so empty, that crossing it seems almost impossible. For now, we can only look across the water, dreaming of what lies beyond. The ocean of the galaxies zoom out further. The Milky Way is a spiral galaxy about 100,000 light-years across. It contains hundreds of billions of stars, each potentially with its own planets. From our perspective, we sit on one of its spiral arms, about 2/3 of the way from the center. The galaxy itself spins slowly, taking 230 million years to complete a single rotation. Think about that. The last time the Sun was in this same position in the galaxy. Dinosaurs walked the Earth. Life rises and falls in the blink of the galaxy's slow turn. And yet, the Milky Way is just one among trillions. The universe is filled with galaxies of all shapes and sizes: spirals, ellipticals, irregular, scattered like grains of sand on a cosmic shore. The limits of sight with telescopes like Hubble and James Webb. We peer deeper into the cosmos than ever before. We see galaxies billions of light-years away. But here's the strange part. We are not looking at them as they are now, but as they were billions of years ago. Light takes time to travel, and the farther we look, the further back in time we see at the very edge of visibility. We approach the beginning of time itself, the faint afterglow of the Big Bang 13.8 billion years ago. That faint light is the cosmic microwave background, the oldest signal in existence. Beyond it, we cannot see, not because there is nothing there, but because the universe has not given us a way to know. The feeling of sky law of this can feel overwhelming. Numbers blur together. Light years, billions, trillions, these words start to lose meaning. And that is natural, because the human mind was not designed for infinity. But the point is not to memorize the numbers. The point is to feel the vastness, to recognize how small we are in comparison. And yet how remarkable it is that we can even ask these questions. We are creatures of a tiny planet, orbiting a modest star in a quiet corner of an ordinary galaxy. And yet, here we are, speaking about billions of years, trillions of kilometers, the fabric of the universe itself. That is the true scale of the universe, not just the distances and the time, but the fact that we, small as we are, dare to measure it. Asterisk when we lift our eyes toward the night sky. What appears to us as scattered points of light is in fact the faintest whisper of an unimaginably vast ocean. Each star you see is not simply a speck on black canvas, it is a blazing nuclear furnace, often millions or billions of years old, suspended in space like a lantern. But the reality goes further. Many of those points of light are not individual stars at all. They are entire galaxies, each containing billions or even trillions of stars. Take the Andromeda galaxy, for instance. To the naked eye, under very dark skies, it appears as a soft blur, almost ghost-like. Yet it holds an estimated 1 trillion stars, 10 times the number of stars in our own Milky Way. And Andromeda is just the nearest spiral giant. Beyond it, telescopes reveal countless more galaxies stretching into every corner of the sky. The scale becomes almost dizzying. Imagine standing on the shore of an infinite ocean. Each wave that breaks before you is another galaxy, another island of light. The Hubble Space Telescope, in one of its most famous images, the Hubble Ultra Deep Field, looked at a patch of sky so tiny that it seemed empty to the human eye. That patch was no larger than a grain of sand held at arm's length. Yet within that minuscule window, thousands of galaxies appeared, each a universe of its own. This means that every direction we look, every grain of sky holds its own cosmic archipelago of galaxies. Astronomers estimate that in the observable universe, there may be 2 trillion galaxies. If each galaxy holds hundreds of billions of stars, then we are staring into a sea of nearly uncountable suns, and yet, as overwhelming as this number is, it's important to remember our instruments can only reach so far. The observable universe is limited by the finite speed of light and the age of the cosmos itself. Light from the most distant galaxies has taken over 13 billion years to reach us. Beyond that horizon, there is more universe, possibly much more that we cannot see, perhaps forever hidden from us. In other words, what we observe is likely just a fraction of what truly exists. Now let's shrink back to our home. The Milky Way galaxy, a spiral system about 100,000 light-years in diameter. It contains perhaps 200 to 400 billion stars. To cross it from end to end at the speed of light would take longer than the entire span of human civilization. Imagine the scale when the first humans lit fires on Earth. Photons from distant stars within our own galaxy had not yet finished their journey across that expanse. Our Sun is just one star among those hundreds of billions, an ordinary yellow dwarf. Not particularly large, not particularly small. And circling around it, a fragile ring of worlds, one of which we call Earth. From the galactic perspective, we are a small island in an endless cosmic archipelago. But the scale goes deeper still. Stars often gather in clusters. Galaxies group into clusters, 2 swarms of hundreds or thousands of galaxies bound by gravity. These clusters themselves form superclusters, gigantic webs of galaxies linked together across hundreds of millions of light-years. And beyond that, on the largest scales, the universe reveals a cosmic web, filaments of galaxies stretching like threads across the void, separated by enormous dark regions where almost no galaxies exist. It is this structure, the cosmic web, that gives the universe its vast architecture. Imagine a spiderweb, except instead of threads of silk, each line is a chain of galaxies. Between those threads are great voids, regions of almost nothingness spanning hundreds of millions of light-years. Our own Milky Way resides in one strand of this web, part of the Laniakea supercluster, a massive galactic neighborhood spanning over 500 million light-years and containing around 100,000 galaxies. And so, when we ask the question, are we alone? We must place ourselves in this staggering context. Each galaxy holds countless stars, and around many of those stars, planets. It would be a cosmic miracle if all of them were barren, if not a single one held life. Yet, despite the enormity, we are still left with silence. The paradox presses upon us. In an ocean so vast, where are the other voices? Still, the scale itself offers comfort as well as mystery. For even if we are alone in this universe of galaxies, we are not without belonging. We are woven into the fabric of this immensity. The very atoms in your body, carbon, oxygen, iron, were forged in the cores of ancient stars, then spread into space by violent supernova explosions. The universe is not something distant or alien. It is within you. You are stardust made conscious, a small but vital part of this immense ocean of light. And so, as you relax into these thoughts, let the immensity be not overwhelming, but soothing. To float in a universe so vast is to be part of a story far greater than ourselves. We are travelers through starlight, listeners in the silence, wanderers in a galaxy that itself is just one small wave in an infinite sea. When we try to grasp the universe's scale, distance and time become deeply intertwined. The farther we look into the cosmos, the further back in time we peer. This is because light, though unimaginably fast, still has a speed limit about 300,000 kilometers per second. It takes light just over a second to reach us from the moon, about 8 minutes from the sun, and over 4 years from the nearest star beyond our solar system. So when you gaze at the night sky, you're not seeing stars as they are now. You are seeing them as they once were. Some of the stars above you may have already burned out, their light still traveling toward Earth across the vast gulf of space. In a way, the night sky is a time machine, a celestial memory of what once was. This deep connection between distance and time means that as our telescopes extend farther, they reveal earlier chapters of the universe's story. When astronomers look at galaxies billions of light years away, they are observing them as they were billions of years ago. The faintest red-shifted smudges captured by the James Webb Space Telescope may represent galaxies that existed less than 1 billion years after the Big Bang. In that sense, the universe offers us a living archive, where the past is written in light and distance. But how does the scale translate to human terms? Let's attempt a thought experiment. Imagine shrinking the universe down so that the entire 13.8 billion year history is represented in a single calendar year, the cosmic calendar, an idea popularized by Carl Sagan. In this model, the Big Bang occurs on January 1st. Galaxies form in mid-January. Our own solar system emerges in early September. Life on Earth begins later that same month. Dinosaurs appear just before Christmas, and humanity. Our recorded history takes place in the final seconds of December 31st, a blink of an eye compared to the vastness of cosmic time. This perspective is humbling. For all our achievements, civilizations, and histories, we have only just arrived on the cosmic stage. The universe was already ancient before a single human ever walked the Earth. The stars that shine above us tonight have burned for eons, indifferent to the fleeting moments of our species. Yet in that brevity lies something profound, despite being latecomers. We are the ones who can contemplate it all. The distances themselves are equally mind-bending. Consider the Voyager 1 spacecraft. Launched in 1977, it is now the most distant human-made object from Earth, more than 24 billion kilometers away. Yet even at that extreme distance, it has only crossed into interstellar space, still within the neighborhood of our Sun, at the speed Voyager travels. It would take over 70,000 years to reach the nearest star. Our current technology makes interstellar travel seem impossibly slow. A reminder of just how immense even the smallest steps into the galaxy truly are. Now scale that to galactic proportions. To travel across the Milky Way 100,000 light-years, wide at the speed of light itself, would take longer than the entire span of human evolution. To cross the observable universe, about 93 billion light-years across, is beyond imagination. And still, cosmologists suspect the total universe may be even larger. Perhaps infinite. From such scales, one might wonder, what do human struggles, hopes, or fears matter at all? Does our smallness mean insignificance? The answer depends on perspective. From one view, we are indeed tiny, a speck within a grand immensity. But from another, our awareness grants us meaning. Out of countless galaxies and stars, here on this small planet, the universe has given rise to beings capable of asking these questions, capable of seeking and wondering. That alone transforms insignificance into significance. Think of it this way: the cosmos is not just out there, detached and foreign. The universe is within us. The calcium in our bones, the iron in our blood, the oxygen we breathe, all were born in the nuclear fires of ancient stars. Those stars lived, burned, and died so that we could exist. In a real sense, the universe has become self-aware through us. Our thoughts, our dreams, even our doubts. Are the universe reflecting upon itself? And so, as we reflect on the scale of the universe, on the billions of galaxies, the trillions of stars, the immeasurable distances, and the vast ages, we return to our original question: are we alone? The sheer abundance of stars and worlds suggests that life, perhaps intelligent life should exist elsewhere. Yet the silence remains. The night sky, for all its countless suns, does not speak to us. This silence is not cause for despair, but for awe. It means we still stand at the threshold of discovery. It means the universe holds mysteries we have yet to uncover. Perhaps civilizations exist too far for us to detect, or perhaps they lived and died long before we arrived. Or perhaps, in all this vastness, we truly are unique for now. Either way, the scale of the universe places us in a position of wonder. We are both fragile and extraordinary, both fleeting and timeless. In contemplating the cosmos, we expand beyond ourselves. And in doing so, we find peace not in answers, but in the beauty of the questions themselves. So, let the immensity calm you. Let the endless distances, the boundless ages, remind you that whatever burdens you carry are but small waves in a much larger sea. You are part of something immense, and in knowing that, you are never truly alone. Asterisk life, in all its beauty and complexity, often feels like a miracle. The flutter of a bird's wings, the rhythm of your own heartbeat. The way thoughts form in your mind, these seem far removed from the cold emptiness of space. And yet, the story of life does not begin on Earth. It begins in the stars. Billions of years ago. Before Earth was even a thought in the universe's mind, stars lived and died in cycles of birth and collapse. Within their blazing cores, lighter elements like hydrogen and helium fused into heavier ones, carbon, oxygen, nitrogen, iron. When massive stars reached the end of their lives, they exploded in supernova, scattering these elements into space. It was in this cosmic crucible that the raw ingredients of life were forged. The calcium in your bones, the oxygen in your lungs, the iron in your blood all were born in the death throes of ancient stars. This is why Carl Sagan famously said, "We are made of star stuff." Life's story is inseparable from the larger story of the universe. The atoms that make you were once scattered across space as cosmic dust, drifting through the void until gravity gathered them together into a newborn star system. One of those stars was our sun. Around it, a swirling disk of gas and dust began to clump into planets. Earth formed roughly 4.5 billion years ago. A fiery ball of molten rock constantly bombarded by asteroids and comets. At first, it seemed utterly hostile, searing heat, toxic gases, and constant impacts. And yet, it was in this chaos that the stage for life was set. Those same comets and asteroids carried water, carbon compounds, and other molecules essential for biology. In a sense, Earth was seeded with the building blocks of life from space. Once the planet cooled, oceans formed, and within them, chemistry began to dance. Lightning struck through a thick atmosphere. Hydrothermal vents belched energy from the deep sea floor. In these cauldrons, simple molecules like methane, ammonia, and water could interact, forming more complex structures. Amino acids, the building blocks of proteins, may have assembled. Lipids, capable of forming protective membranes, may have enclosed small pockets of molecules. The transition from simple chemistry to life is one of the greatest mysteries in science. Did life begin in shallow ponds struck by lightning? Or in the deep ocean, where mineral-rich vents offered both shelter and energy? Or perhaps life arrived from beyond, carried here by icy comets in a process called panspermia? We do not yet know. But what we do know is that once the right conditions emerged, molecules began to organize themselves in ways that hinted at life. The breakthrough may have come with RNA, a molecule capable not only of carrying information, but also of catalyzing chemical reactions. Imagine strands of RNA forming spontaneously in some ancient tide pool, copying themselves imperfectly, competing for resources. Some copies lasted longer, others broke apart. Over time, the better survivors became more common. In this way, evolution, life's great engine may have begun even before the first true cell existed. Eventually, RNA and proteins may have been enclosed by lipid membranes, creating the first primitive cells. They were tiny, fragile, and unimaginably simple compared to modern life, yet they marked a turning point. For the first time, the universe contained structures that could replicate, evolve, and grow. These early cells, known as prokaryotes, were Earth's only inhabitants for billions of years. They lived in oceans, in sediments, around hydrothermal vents. Slowly, they began to alter the planet. Around 2.5 billion years ago, some developed a remarkable trick: photosynthesis. Using sunlight, they could convert carbon dioxide and water into energy, releasing oxygen as a byproduct. This event, sometimes called the Great Oxidation Event, changed everything. The atmosphere filled with oxygen, paving the way for more complex forms of life. It was not an easy transition. Mild oxygen was toxic to many early organisms, and mass extinctions followed. But in the long run, oxygen allowed for the rise of cells with internal complexity, eukaryotic cells that contained a nucleus and organelles. These were the ancestors of plants, fungi, and animals. From these humble beginnings, life on Earth began its long journey of diversification. Yet it is worth pausing here, at the dawn of life, to reflect. Out of cosmic dust and violent chaos, chemistry learned to breathe. The universe, once silent, began to hum with biology. And in time, that biology would learn to think, to dream, and to ask the very question we are asking now: where did we come from? As you let these thoughts settle, remember that the atoms in your body were once scattered across the stars, drifting through the cosmos before they came together in you. You are the product of billions of years of cosmic history and planetary transformation. And though we may never know every detail of life's origins, the wonder lies not only in the answers, but in the mystery itself. After billions of years of solitude, Earth's earliest cells had carved out a place for themselves in oceans and sediments. They were small, simple, and for a long time they changed little. If you could peer into Earth's seas 3 billion years ago, you would not see fish or plants or anything resembling what we know today. Instead, you would see vast microbial mats, thin films of bacteria covering rocks, shallow waters, and hot springs. These organisms were Earth's pioneers, slowly shaping the chemistry of the planet. The rise of photosynthesis was the first major revolution. By harnessing sunlight, some bacteria could generate their own food and release oxygen into the air and seas. At first, this was catastrophic. Oxygen was a poison to many forms of life that had evolved in an oxygen-free world. But evolution thrives on challenge. Slowly, organisms adapted, finding ways to use oxygen for energy. This was a profound shift because oxygen unlocks far more energy than older chemical processes. With more energy available, life could afford to become more complex. Somewhere around 2 billion years ago, a second great leap occurred. One cell engulfed another, not to consume it, but to cooperate with it. Instead of digestion, this relationship became symbiotic. The engulfed cell became what we now call a mitochondrion, the powerhouse of the cell providing energy to its host. This was the birth of eukaryotic cells, which would eventually give rise to all plants, animals, and fungi. Without this ancient partnership, complex life as we know it would never have emerged. From here, cells learned to specialize and cooperate in new ways. Some began to cluster together, sharing tasks. A few of these clusters discovered that by sticking together, they could accomplish more than they could alone. This was the origin of multicellularity, a step that eventually allowed organisms to grow larger, develop tissues, and explore new forms. For hundreds of millions of years, multicellular life remained simple: tiny colonies, small filaments, rudimentary bodies. But the seeds had been planted for the grand drama to come, around 600 million years ago. The stage was set for one of the most extraordinary events in life's history, the Cambrian explosion. In a relatively short span of geological time, perhaps 20 to 30 million years, life diversified in ways it never had before. Suddenly, the seas filled with strange and wondrous creatures, trilobites scuttling along the seafloor, worm-like predators with circular jaws, armored animals with spines and shells. Many of the body plans that exist today, backbones, exoskeletons, limbs emerged during this period. Why did this explosion happen? Scientists are still debating. Perhaps oxygen levels had finally reached a threshold that made complex life sustainable. Perhaps the evolution of vision eyes that could detect light and shapes sparked an evolutionary arms race between predator and prey. Or perhaps Earth's environment stabilized after long cycles of ice ages, allowing ecosystems to flourish. Whatever the cause, the Cambrian explosion was like a cosmic unveiling. For billions of years, life had been microscopic and hidden. Suddenly, it became visible, dynamic, and diverse. Imagine Earth's oceans at that time, coral-like structures providing shelter. Schools of small creatures darting through the water, predators lurking in the depths. It was alien, yet profoundly familiar, for it was the foundation of the biological world we know today. Every fish, every bird, every mammal, every human in our lineage can be traced back to those early experiments in complexity. It is worth remembering just how precarious this journey was. Life's progression was not inevitable. It was a story written through chance and survival, through countless extinctions and narrow escapes. At several points in Earth's history, life nearly vanished. Massive volcanic eruptions, asteroid impacts, and climate shifts threatened to reset the clock. And yet, life endured. Fragile cells gave rise to resilient ecosystems, and resilience gave rise to innovation. In reflecting on this, we find a certain comfort. For if life could survive the chaos of Earth's early history, and then bloom into such diversity, it suggests that resilience is built into the very fabric of biology. And perhaps, if conditions are right, similar journeys might unfold on distant worlds as well. Pause for a moment and imagine the story as a grand timeline. At first, only darkness and chaos. Then stardust becomes planets, oceans, and chemistry. Then chemistry becomes cells. Cells become partners. Partners become communities. And communities explode into ecosystems. Each step a miracle, yet each grounded in the laws of nature. As you relax into this thought, recognize the continuity. You are part of that same story. The spark of life that began in ancient seas flows unbroken into you. The cells in your body carry the echoes of those first cells, the same molecular machinery, the same resilience. When you breathe, when your heart beats, you are carrying forward a 4 billion-year-old legacy. And so, as the Cambrian seas teemed with new life, the stage was set for the next chapter's life moving onto land. Adapting to air, growing forests, and eventually walking upright as humans. But even before those grand steps, the origin of complexity itself is a reminder. Life is not static. It is restless, creative, and persistent. From a single cell to countless forms, life is the universe's way of exploring possibility. Asterisk. If the origin of life could be summarized in one challenge, it would be this. How do you get from simple molecules to something that can replicate, evolve, and persist? This leap from chemistry to biology's the most profound transition in Earth's history. In the last section, we explored chemical building blocks like amino acids and nucleotides. Now, we venture into how those building blocks could have crossed the divide into life itself. The RNA world hypothesis, 1. Of the most compelling ideas is known as the RNA world hypothesis. RNA, short for ribonucleic acid, is a versatile molecule. Today, it plays the role of messenger between DNA and proteins. But RNA can also act like an enzyme, folding into complex shapes that catalyze reactions. Scientists have discovered ribozymes are Na molecules with enzymatic activity capable of cutting and joining other RNA strands. This dual function means RNA could have been the perfect candidate for early life, a molecule that both stores information and performs chemical work. Experiments have shown that under plausible prebiotic conditions, short RNA strands can form spontaneously. Researchers have even evolved ribozymes in the lab that can replicate pieces of RNA. While we are far from creating a fully self-replicating RNA system, the RNA world remains a leading explanation for how the first proto-life may have operated. The role of lipids, making boundaries. Molecules alone aren't enough. To become alive, chemistry needs boundaries. Life requires a separation between the inside and the outside. This is where lipids, fat-like ATIA molecules, center the story. Remarkably, under the right conditions, lipids naturally organize into tiny spheres called vesicles. These vesicles form spontaneously in water, creating enclosed spaces much like primitive cell membranes. Inside these compartments, chemical reactions can happen in relative isolation. Imagine a tide pool filled with billions of microscopic bubbles, each one its own miniature laboratory. Some vesicles may have accidentally trapped RNA strands or other reactive molecules. Those vesicles where chemistry worked better, where RNA replicated more efficiently, or where molecules worked cooperatively, would persist longer. This creates a rudimentary form of selection, long before life as we know it emerged. Autocatalytic networks. Another pathway to life comes from the idea of autocatalytic networks. This is the concept that molecules could form a self-sustaining system where each part helps produce the others. Think of it as a web of chemical reactions, where molecule A makes molecule B helps produce molecule C, and molecule C loops back to support A. Such networks don't require perfect replication, only stability and growth. Stuart Kauffman, a complexity theorist, argued that once chemistry reached a certain level of diversity, autocatalytic sets would almost inevitably emerge. If true, this would suggest that life is not a freak accident, but a probable outcome of chemical richness. The first, metabolisms. Alongside replication, life also requires metabolism, the ability to harness energy. The metabolism first hypothesis suggests that primitive metabolic cycles may have arisen on mineral surfaces, especially near hydrothermal vents. Certain minerals can catalyze the reduction of carbon dioxide into organic molecules, feeding into loops of reactions that resemble the core of modern metabolic pathways. For example, parts of the Krebs Secula central metabolic process in all modern cells can be recreated abiotically under vent-like conditions. This hints that metabolism may have begun before genetics, laying a foundation for life that could later integrate RNA or other replicating molecules. The great integration, genes plus metabolism plus membranes. So, which came first, genes, metabolism, or membranes? This is the crux of the debate. But perhaps the better answer is that all three co-evolved in a messy, interconnected process. Membranes provided compartments. RNA provided replication. Metabolic cycles provided energy. Over time, these systems likely reinforced each other until, somewhere in Earth's early history, the first true cell was born. The first cells would have been incredibly simple, nothing like the bacteria or archaea we know today. But they carried the essential features: a protective boundary, the ability to replicate, and the means to draw energy from their environment. From that humble beginning, evolution had something to work with: the transition to DNA and proteins. Once life established itself, further innovation followed. RNA is good, but it's relatively fragile. At some point, life invented DNA, a more stable molecule to store information. Proteins made of amino acids. also took over as the primary enzymes because they could perform chemical reactions far more efficiently than RNA. This division of labor DNA for storage, RNA for messaging, proteins for work remains the foundation of life to this day. Lessons for as flew by. The story of life's origins isn't just about Earth. These concepts guide how we search for life beyond our planet. If lipids self-assemble anywhere, if RNA-like molecules can emerge under diverse conditions, if autocatalytic networks are natural consequences of chemistry, then life might not be unique to Earth. It could be a common outcome wherever conditions allow. Hydrothermal vents on icy moons like Europa or Enceladus may host similar chemical processes. Titan, with its methane lakes, may offer entirely different pathways to life. The question is no longer just did life happen here, but is life a universal expression of chemistry? The mystery remains, and yet, despite decades of experiments, we do not have a definitive answer. We can simulate parts of the puzzle building blocks, compartments, replication, but we haven't yet watched non-life cross the threshold into life in a lab. The origin of life remains one of the greatest unsolved mysteries in science. Perhaps the most humbling truth is this: we may never pinpoint the exact moment when chemistry became biology. The Earth erased its earliest history billions of years ago. What we're left with are clues, possibilities, and models that suggest it could have happened in multiple ways. A. Philosophical reflection. The origins of life raise questions beyond science. Was life inevitable once conditions were right, or was it a cosmic fluke? If inevitable, then the universe may be teeming with life. If rare, then we may be utterly alone. Either way, the fact that life emerged here means that the universe, at least once, organized itself into beings that could look back and wonder at their own origins. And in that sense, the study of life's beginnings isn't just about science. It's about understanding our place in the cosmos. The universe is vast, unimaginably so, filled with billions of galaxies, each containing billions of stars, many of which host planets in the so-called habitable zones. If life can arise on Earth, why wouldn't it arise elsewhere? This question lies at the heart of the Fermi Paradox, a simple yet profound puzzle. Given the vast number of potentially habitable worlds, why have we seen no evidence of intelligent life? Why does the cosmos seem silent when it should be teeming with civilizations? The paradox is named after physicist Enrico Fermi, who, in the 1950s, famously asked, "Where is everybody?" It is not just a philosophical question. It is deeply scientific. Consider the Drake equation, which attempts to estimate the number of civilizations in our galaxy with which we might communicate. The equation multiplies factors such as the rate of star formation, the fraction of stars with planets, the number of planets that could support life, the probability of life actually arising, the probability of intelligent life evolving, and the lifespan of technological civilizations, even using conservative numbers. The results suggest that the Milky Way alone could harbor thousands, if not millions, of civilizations. Yet, despite decades of listening, we have detected nothing. No signals, no signs, no probes or artifacts. Radio telescopes sweep the skies in programs like SETI, monitoring nearby stars and galaxies, but the silence persists. This is not for lack of trying. The search has been extensive, the methods sophisticated, and this silence only deepens the mystery. One proposed explanation is that intelligent life is exceedingly rare. Perhaps the emergence of complex life requires a precise series of circumstances, a delicate sequence of events that only happened on Earth, the right chemical composition, the right planetary size, the presence of a large moon, the stability of climate over billions of years. Maybe these factors are uncommon, making civilizations like ours extremely rare in both time and space. Another possibility is that civilizations are common, but they tend to destroy themselves before becoming capable of interstellar communication or travel. Humanity itself offers a cautionary example. Technological advancement comes with existential risk, from nuclear weapons to climate change. Perhaps most civilizations reach a point where they extinguish themselves, leaving behind no detectable traces. The silence of the cosmos could be the result of repeated self-destruction, an invisible filter that prevents long-lived civilizations from appearing. Yet, another hypothesis suggests that civilizations are deliberately avoiding us. Perhaps intelligent species recognize the dangers of revealing themselves and maintain a policy of non-interference. The analogy is drawn to humans observing less advanced species on Earth, choosing not to disrupt their development. In this view, the universe may be quietly populated, but each civilization exercises caution, remaining undetectable to others. There is also the chance that communication is far more difficult than we imagine. Perhaps extraterrestrial civilizations do not use radio waves at all. They might rely on technologies that are beyond our current understanding, signals so subtle or fleeting that we fail to notice them. Alternatively, the timescales of civilizations could be misaligned with our own. A civilization might rise and fall in a span of thousands of years, mere instant in cosmic time, while we happen to exist in a quiet interval between bursts of galactic activity. Some scientists consider the idea that intelligent life may be common, but spread too thinly across the galaxy. The distances are staggering. Even traveling at a fraction of the speed of light, reaching nearby stars would take decades or centuries. For a civilization to colonize the galaxy would require not just advanced technology, but an immense amount of time and resources. Perhaps interstellar travel is so challenging that civilizations remain confined to their own stellar neighborhoods, leaving the galaxy largely silent from our perspective. The Fermi Paradox also invites philosophical reflection. Maybe life is common, but intelligence is rare. Complex life on Earth took billions of years to emerge, and technological intelligence only arose very recently in our planet's history. Perhaps intelligence is an evolutionary accident, not an inevitable outcome of life. This could explain the absence of detectable extraterrestrial civilizations, even if life itself is abundant. And yet, the paradox is not merely a pessimistic thought experiment. It also serves as a reminder of the preciousness of life and intelligence. Humanity, though small and young, may represent a rare phenomenon in the galaxy, a conscious observer capable of understanding the cosmos. The silence we perceive could make our own existence more remarkable, not less. As we peer deeper into the Fermi Paradox, we are confronted with both uncertainty and possibility. Each hypothesis, whether life is rare, civilizations self-destruct, or intelligent beings remain hidden, carries profound implications. We are forced to ask not only what is out there, but what our place is within the cosmic narrative. Are we pioneers in a lonely galaxy, observers of a silent universe, or part of a hidden community of civilizations awaiting contact? The vastness of space reminds us that time and distance may be working against our perception. A signal sent from a distant star might take millions of years to reach us, or we might have missed signals already sent because we were not listening at the right moment. The universe is both ancient and immense, and our brief human lifespan allows only a narrow window in which we can search for others. Still, the search continues. Projects dedicated to scanning the skies, analyzing unusual cosmic phenomena, and even sending messages into space reflect humanity's enduring curiosity. The Fermi Paradox is not a dead end. It is an invitation, a challenge to expand our understanding, to look beyond immediate silence, and to consider new ways of thinking about life, communication, and intelligence. As we delve deeper into the Fermi Paradox, one concept looms large: the Great Filter. This idea suggests that somewhere along the path from simple life to advanced civilization, There exists a stage so difficult to pass that very few or possibly no species make it through. The great filter could lie behind us. In which case, the emergence of intelligent life on Earth was an extraordinary stroke of luck. It could also lie ahead, suggesting that advanced civilizations inevitably face challenges that prevent them from surviving long enough to colonize the galaxy. If the filter is behind us, then we have already passed the most improbable steps, the transition from chemistry to life, from single-celled to multicellular organisms, or the evolution of intelligence itself. In this scenario, Earth represents one of the rare success stories in the cosmos, a remarkable alignment of conditions that allowed a technological civilization to arise. That possibility fills us with awe at the fragility and uniqueness of our own existence. Conversely, if the filter is ahead, the silence we perceive may be a warning. Perhaps the development of advanced technology, space travel, nuclear energy, artificial intelligence inevitably brings existential risks. Civilizations that fail to manage these challenges might self-destruct before making their presence known across the stars. Humanity may be approaching this filter ourselves, which would make the Fermi Paradox not just a theoretical puzzle, but a deeply practical concern. Another angle considers the behavior of potential extraterrestrial civilizations. Perhaps life is common, but intelligent species do not expand aggressively. They may practice caution, avoiding interference with emerging civilizations, or they may value sustainability over conquest. It is possible that cosmic cultures exist not as empires spreading across galaxies, but as civilizations confined to their own worlds or star systems, focused on exploration, research, or internal development rather than outward expansion. Some theorists speculate about communication methods beyond our detection capabilities. Advanced civilizations might not rely on electromagnetic signals like radio or laser beams, but on entirely different forms of communication, such as neutrinos, gravitational waves, or technologies we have yet to conceive. They may also send signals so subtle or encoded that they appear as natural cosmic noise to us. From our limited perspective, the universe would appear empty, while in reality it is teeming with activity beyond our comprehension. The timing of civilizations adds another layer of complexity. The universe is 13.8 billion years old, but intelligent life on Earth has existed for only a tiny fraction of that time. It is possible that many civilizations rose and fell long before humans appeared, leaving no detectable trace. Others may emerge long after we are gone. The silence is not proof of absence, could simply reflect mismatched timelines, vast distances, or the brief window in which a civilization broadcasts signals detectable by others. There is also the consideration of resource limits. Interstellar travel and communication may require enormous energy and technological sophistication. Civilizations might choose to focus inward, optimizing their local planets and societies rather than investing in risky and resource-intensive exploration. A galaxy filled with cautious, localized civilizations could appear silent, even if life is abundant. Speculation about extraterrestrial motives is unavoidable. Some suggest that advanced civilizations may deliberately remain hidden, avoiding contact with less developed species to prevent cultural contamination or conflict. Others propose that we are simply not interesting or visible enough on a galactic scale, much like ants on a planet unnoticed by humans. The possibilities challenge our assumptions about life, intelligence, and behavior beyond Earth. Yet the Fermi Paradox is not just a reflection of absence. It is also an opportunity to reflect on humanity's potential. We are one of the few species we know capable of contemplating the cosmos and questioning our place within it. The silence may be an invitation to look inward as much as outward, to protect our civilization, manage our technology responsibly, and explore space with wisdom and care. Finally, the paradox reminds us of the scale and mystery of the universe. It emphasizes how tiny and brief our existence is. Yet it also illuminates our capacity for curiosity, innovation, and reflection. The universe may seem empty from our perspective, but in probing the question of whether we are alone, we are participating in a dialogue with the cosmos itself, conversation that stretches across billions of light years and billions of years of time in contemplating the great filter, the limits of technology, and the behavior of hypothetical alien civilizations. We confront both awe and responsibility. We face the realization that life may be rare, intelligence may be fleeting, and the silence we perceive may be a challenge to ensure our own survival. At the same time, we recognize that we have the ability to shape our destiny, to push the boundaries of knowledge, and perhaps one day to answer Fermi's eternal question for ourselves: where is everybody? As we move toward possible resolutions to the Fermi Paradox, it becomes clear that the answers may not be simple or singular. One idea is that the universe is full of life, but advanced civilizations are so different from us that we fail to recognize them. Their technology may be incomprehensible, their forms of existence alien beyond imagination. We might be looking for a radio signal or a physical artifact when in reality they communicate or travel through means we cannot yet perceive. The cosmos could be bustling with intelligence, yet remain invisible to our limited senses and current instruments. Some scientists consider that civilizations may deliberately avoid spreading across the stars, not out of inability, but by choice. A civilization capable of interstellar travel might see expansion as unnecessary or even risky. They may value stability, sustainability, and longevity over colonization. In this scenario, the quiet of space is a reflection of caution, not absence. Civilizations could be quietly observing one another, maintaining a cosmic etiquette that keeps the galaxy peaceful, but seemingly empty. The concept of the Great Filter continues to resonate in this discussion. If the filter is behind us, the emergence of human civilization might represent an extraordinary stroke of luck, a rare event in an otherwise indifferent cosmos. If the filter is ahead, the silence we observe could be a warning. Civilizations that reach our technological level may face unavoidable dangers, from self-destruction to cosmic hazards. Either way, the Fermi Paradox highlights the fragility and preciousness of intelligent life. There is also the temporal aspect to consider. Civilizations might exist, but not overlap with ours in time. The universe is ancient, billions of years older than human civilization. Civilizations may rise and fall, leaving behind only faint traces that disappear over geological and cosmic timescales. It is possible that many civilizations have existed before us, and many more will arise after we are gone. The silence we perceive is, in this sense, a matter of perspective and timing. Distance and scale are also critical. The Milky Way alone spans 100,000 light-years. Even at near-light speeds, reaching another star is a monumental challenge. Signals take years, decades, or millennia to travel across space. A civilization might broadcast for only a short period, and unless we are listening at precisely the right time, we will never hear it. The vastness of space and the brief window of detectability may create a natural communication gap, explaining why the cosmos seems silent despite possible abundance. Another possibility is that intelligent life is extremely rare, and humanity represents one of the very few, if not the only, technological civilizations in our galaxy or even the observable universe. Life itself may be relatively common, but the leap to complex intelligence, tool use, and interstellar communication could be extraordinarily improbable. In this sense, we may be a rare cosmic phenomenon, alone in observing and reflecting on the universe. Philosophically, the Fermi Paradox invites reflection on our own responsibility as a civilization. If life is rare or fleeting, our survival becomes a cosmic imperative. The very act of sustaining our civilization, protecting our planet, and exploring space may carry greater weight than we typically recognize. The silence of the universe reminds us of the fragility of intelligence and the need for foresight, cooperation, and stewardship. Speculation extends to future possibilities. Perhaps humanity itself will become part of the solution to the paradox. With advancing technology, we might detect signals from previously hidden civilizations, or create interstellar probes that traverse the galaxy. We might encounter life forms that challenge our understanding, expanding the definition of intelligence and presence. The resolution of the paradox may not come solely from observation, but from our own expansion and exploration. Ultimately, the Fermi Paradox is both a scientific and philosophical puzzle. It asks why, given the vastness and apparent suitability of the universe for life, we have not yet seen evidence of others. Its significance lies not only in the search for extraterrestrial civilizations, but in the questions it raises about the rarity, resilience, and responsibilities of intelligence. Whether we are alone or one among many. The paradox encourages humility, curiosity, and vigilance as you contemplate the vast, silent cosmos. Consider this: the absence of evidence is not evidence of absence. The universe may be alive with possibilities, with civilizations existing in forms we cannot yet comprehend or detect. Or perhaps the silence is a reflection of the delicate balance required for life and intelligence to persist. Either way, the Fermi Paradox compels us to think deeply about our place in the cosmos, the fragility of our civilization, and the profound mystery of whether we are truly alone in this reflection. There is both awe and responsibility. Humanity's search for knowledge and connection is itself a testament to the potential of intelligence. The silence of the universe may be temporary, a challenge waiting for us to rise to it. And even if no other civilizations exist, the very act of understanding our place in the cosmos is a remarkable achievement. Bridge between the infinite universe and the conscious mind capable of asking, "Where is everybody?" Imagine for a moment that humanity is truly alone in the universe, that the stars, for all their brilliance and multitude, host no other sentient beings, no other civilizations pondering their existence. At first, such a notion may feel lonely, even frightening. The vast cosmos, once imagined as a crowded arena of life, suddenly becomes a silent expanse where the only conscious observers are us. Yet within this apparent solitude lies an extraordinary responsibility and a unique kind of wonder. If we are alone, then the story of life, consciousness, and intelligence is ours to steward. Every discovery, every innovation, every moment of understanding is a product of an incredibly rare phenomenon, a species capable of reflecting on its own place in the cosmos. In the context of nearly 14 billion years of cosmic history, humans are a brief but meaningful spark. Life on Earth has persisted through unimaginable odds-mass extinctions, climate upheavals, cosmic impacts, and eventually produced beings capable of thought, curiosity, and imagination. Being alone carries weighty implications for our civilization. It means that the survival of intelligent life depends on us. The stewardship of Earth and the preservation of our species become not just moral imperatives, but cosmic responsibilities. If life is a rarity, then its continuation is precious. Our choices, both local and global, reverberate far beyond the immediate confines of our planet. The preservation of knowledge, the nurturing of diversity, and the pursuit of sustainability are all acts that safeguard the presence of consciousness in the universe. Consider the fragility of our situation. Technological civilization, for all its achievements, is vulnerable. Environmental collapse, nuclear conflict, pandemics, or unforeseen cosmic events could end humanity's story abruptly. If we are alone, these risks are not just threats to a single species, they are threats to the continuation of intelligence itself. The absence of other civilizations means no one else will inherit or preserve the knowledge we have accumulated. We are the caretakers of the universe's conscious memory, yet solitude also presents opportunity. Without competing intelligences, humanity has the freedom to chart its own course. We are unbound by external civilizations, free to explore, innovate, and create. The stars are ours to reach, the knowledge of the cosmos ours to uncover. The silence of the universe does not diminish our significance. It amplifies it. Our curiosity, exploration, and creativity take on a unique value precisely because they are acts performed in a vacuum of conscious observers. Reflecting on solitude also changes our perspective on achievement. Every work of art, every scientific breakthrough, every cultural milestone becomes more than a local accomplishment. It is a testament to the capability of consciousness to arise and flourish. If no one else exists, then our achievements resonate across the universe as singular expressions of thought, imagination, and curiosity. Humanity becomes both artist and historian, philosopher and explorer. The soul witnesses to the grandeur of existence. There is a paradoxical beauty in this scenario. The vastness of space, once imagined as a potential stage for countless civilizations, becomes a canvas upon which our story unfolds. Each discovery of distant galaxies, each measurement of cosmic phenomena, each step in understanding the laws of nature is a dialogue with the universe itself. The universe, silent and empty in terms of other observers, becomes a mirror reflecting our own capacity for thought and reflection. If we are alone, it also emphasizes the importance of connection among ourselves. With no other civilizations to compare, to challenge, or to collaborate with, humanity's relationships, societies, and cultures take on amplified significance. Every act of cooperation, every effort to preserve knowledge and pass it on, becomes part of the collective endeavor to sustain intelligence in the universe. The bonds we form, the empathy we cultivate, and the wisdom we share gain cosmic importance. This realization invites a rethinking of our priorities. Solitude at a universal scale encourages us to value sustainability, resilience, and foresight. We may be the only civilization capable of preventing extinction, exploring the stars, and reflecting on existence. Every choice matters more. Every act of discovery and preservation becomes a step in ensuring that intelligence endures. Our collective responsibility is unprecedented, but so too is the opportunity. Being alone also reframes our relationship with time. The universe is ancient, and human civilization is but a fleeting moment in cosmic history. Yet even this brief flicker of consciousness allows us to look back across billions of years of cosmic evolution, to understand the formation of stars and planets, the emergence of life, and the delicate processes that led to our existence. Alone or not, we are participants in a story that stretches across time, capable of witnessing and interpreting events far beyond our immediate perception. Finally, solitude fosters humility and wonder. In the absence of other intelligent observers, we are reminded of the rarity and fragility of life. Every living being, every ecosystem, every molecule that supports life becomes part of an extraordinary chain that culminates in consciousness. The universe, though vast and seemingly empty, is enriched by the presence of thinking, reflective beings capable of appreciating its complexity. As you listen and imagine this scenario, consider that solitude need not imply insignificance. On the contrary, it highlights the uniqueness and value of human life. The universe may be silent, but within that silence, our consciousness becomes a beacon. If we are truly alone, we are entrusted with a profound legacy to understand, to explore, to preserve, and to marvel. We are the universe thinking about itself, the first and perhaps only witnesses to the grandeur of existence. If humanity is the only intelligent life in the universe, the implications ripple far beyond science into philosophy, ethics, and society. One of the first questions this raises is about purpose. Without other civilizations to compare ourselves to, our existence must derive meaning from within. Our goals, achievements, and ambitions become self-contained, born not from competition or recognition, but from our own curiosity, creativity, and desire to understand. The vast silence challenges us to find significance in our own actions and in the stewardship of life. Itself, societal structures would take on a new dimension of responsibility. Governance, culture, and education are no longer just human concerns. They become cosmic imperatives. Every decision that affects the planet's future gains added weight. Environmental preservation, scientific progress, and the fostering of sustainable societies are not merely practical necessities. They become acts of cosmic preservation. In a universe devoid of other observers, the continuation of intelligence rests entirely on our collective shoulders. This isolation also reframes the way we view technological advancement. Space exploration, once a frontier among many, becomes an existential duty. Expanding beyond Earth is no longer just about curiosity or ambition. It is about safeguarding life and consciousness itself, colonizing other planets, harnessing resources responsibly, and developing technologies to survive cosmic hazards are not optional. They are essential for the long-term survival of intelligence. In essence, humanity becomes both the explorer and the guardian of existence. Emotional, and philosophical consequences are equally profound. The absence of other sentient beings may amplify feelings of solitude, but it also provides a unique form of freedom. We are unbound by external pressures from other civilizations, able to define our own ethical systems, cultural expressions, and philosophical frameworks. Solitude can inspire creativity, introspection, and a deeper appreciation for the complexity of our own species. It allows us to cultivate empathy, understanding, and cooperation among ourselves, emphasizing that our connections to each other are the most significant bonds in the cosmos. The notion of being alone also reshapes the value of knowledge. Scientific discovery, rather than being a competitive enterprise among civilizations, becomes a sacred responsibility. Every insight into physics, chemistry, biology, or cosmology is a contribution to the collective understanding of existence. In a universe without peers, our discoveries are not merely practical tools, they are the sole record of intelligent comprehension. The universe's own reflection realized through human thought. Moreover, being alone highlights the urgency of preservation. Earth, as the cradle of life and intelligence, becomes a treasure of unparalleled importance. The conservation of biodiversity, the protection of ecosystems, and the maintenance of planetary stability are no longer local or national concerns. They are acts of cosmic significance. Humanity must recognize itself as the guardian of not only its own species, but of the very phenomenon of conscious life. Every extinction, environmental degradation, or lost opportunity diminishes the presence of intelligence in the universe. Philosophically, this scenario prompts reflection on the nature of meaning and fulfillment. Without other civilizations to compete with or learn from, humanity's purpose emerges from its own endeavors. Creativity, science, art, philosophy, and exploration become expressions of a universe capable of reflection. Our achievements are amplified by the absence of external observers. In solitude, the act of understanding, creating, and contemplating becomes inherently valuable. The silence of the cosmos transforms from a void into a canvas, one upon which humanity paints the story of consciousness. Psychologically, the awareness of being alone can foster both humility and awe. We are reminded of our fragility, the narrow window through which life, intelligence, and civilization have emerged. Yet this awareness also inspires a sense of wonder. Against staggering odds, the universe produced a species capable of reflection, inquiry, and imagination. The rarity of intelligent life magnifies the significance of our experiences, our choices, and our curiosity. Every moment of discovery, connection, or creation is not merely personal or local. It resonates across the universe as a singular manifestation of consciousness. The cosmic perspective also redefines mortality and legacy. With no other civilizations to inherit knowledge, the survival of human culture and memory becomes paramount. Libraries, digital archives, space-based repositories, and the preservation of stories, art, and science become vital. Every effort to safeguard understanding becomes a way to ensure that consciousness endures beyond the fleeting span of individual lifetimes. In this context, the human quest for knowledge and continuity is an existential mission of unprecedented scale. Finally, solitude invites us to embrace humility alongside ambition. The universe is immense and ancient, and the fact that conscious life exists at all is extraordinary. If we are alone, humanity is the universe's only mind capable of reflecting on its own nature. This perspective encourages responsible stewardship, philosophical reflection, and an enduring commitment to the pursuit of knowledge. Solitude, rather than diminishing our significance, magnifies it. We are both a miracle and a responsibility, a rare consciousness entrusted with the task of understanding, exploring, and preserving the cosmos. In sum, the possibility that we are alone is not a limitation, it is an invitation. It challenges us to define purpose from within, to protect life and intelligence, and to expand our reach across the stars. It calls on us to find meaning in exploration, discovery, and creation. The universe may be silent, but within that silence, humanity's consciousness becomes a beacon, a testament to the fragility, rarity, and brilliance of life. In contemplating the possibility that we are alone, one cannot help but reflect on the opportunities that solitude presents. Without other civilizations to influence or compete with us, humanity has the freedom to shape its destiny. Every decision we make, scientific, cultural, technological, and ethical, becomes a defining factor in the legacy of intelligence itself. Our choices reverberate across time, for the actions of one species may be the only conscious reflections in a vast, silent universe. Space exploration, in this context, is no longer merely an ambitious endeavor. It is a duty. Colonizing other planets, developing self-sustaining habitats, and mastering interstellar travel become essential for the preservation and continuity of intelligent life. Humanity must expand its presence beyond Earth, not as an act of conquest, but as an investment in survival. Every step we take into the cosmos ensures that consciousness, in its most refined form, continues to exist even in the face of cosmic threats. Scientific inquiry also gains unprecedented significance. Each discovery, from understanding the laws of physics to mapping the farthest reaches of the universe, is a contribution to the sum of knowledge that may, in the absence of other civilizations, remain solely in our care. We become the keepers of understanding, the chroniclers of existence, and the architects of a legacy that could endure for millennia or longer. Our curiosity, imagination, and analytical ability transform into the tools for preserving the phenomenon of consciousness. Solitude also provides the opportunity for introspection and growth. Without the distraction of external civilizations, humanity can focus on mastering itself socially, ethically, and spiritually. Cooperation, empathy, and wisdom become paramount. The way we treat one another, the choices we make as a species, and the values we cultivate may define the survival and flourishing of intelligence across generations. In this sense, our society becomes both a laboratory and a sanctuary for the future of life. Art and culture acquire an added dimension. Every work of art, music, literature, or philosophical thought becomes not only a reflection of human experience, but also a permanent record of conscious existence. These creations, if preserved, will outlast generations. perhaps serving as the universe's only testament to intelligent reflection. In solitude, the act of creation is magnified, for it is both an expression of identity and a bridge between the ephemeral present and the distant future. The ethical implications of being alone are profound. Environmental stewardship, technological development, and planetary protection are elevated from choices to imperatives. Our responsibility extends not just to current life, but to all future manifestations of intelligence that might depend on our survival and ingenuity. We must avoid short-sighted actions that could erase the rare phenomenon of consciousness. For failure may mean permanent silence in the universe. Yet solitude is not solely about caution and preservation. It is also about inspiration. The absence of other intelligent life challenges us to dream boldly, to imagine civilizations of the future, and to strive for progress in ways that may never be mirrored elsewhere. Our science, philosophy, and exploration are acts of pioneering in the truest sense, not constrained by precedent or comparison. Every discovery, whether on Earth or across the stars, becomes an achievement of unparalleled significance. Time becomes a critical factor in this reflection. The universe's age dwarfs the brief span of human civilization. Yet it is precisely within this brief window that we have the ability to act, to create, to explore, and to preserve. Every decade of scientific advancement, every expansion into space, and every effort to sustain life contributes to a cosmic narrative that may otherwise remain unwritten. Humanity is both witness and participant, responsible for ensuring that consciousness persists beyond the fragility of a single planet. Moreover, being alone encourages us to contemplate the nature of intelligence itself. What does it mean to think, to reflect, and to seek understanding in a universe that may hold no peers? Solitude amplifies the significance of human thought and inquiry, revealing the profound value of our cognitive abilities. In a universe devoid of other conscious beings, our reflections, questions, and insights become the singular lens through which the cosmos may be understood. Ultimately, if we are truly alone, the universe has entrusted us with a remarkable opportunity. Humanity can become the enduring observers, explorers, and chroniclers of existence. We may shape civilizations of the future, expand life beyond Earth, and cultivate a legacy of thought and creativity that stretches across millennia. The silence of the cosmos is not emptiness, it's a call to action, an invitation to stewardship, and a reminder of the rare and extraordinary nature of consciousness as you contemplate this possibility. Imagine the weight and the beauty of such responsibility. The universe may be silent, but in that silence, we have the capacity to become its voice. Through exploration, preservation, and understanding, humanity can transform solitude into purpose, isolation into inspiration, and rarity into enduring significance. In the quiet expanse of the cosmos, we are the conscious spark, the thinking eyes, and the mindful caretakers of all that is and all that may come. Imagine, for a moment, that we are not alone in the universe, that somewhere among the countless stars, planets, and galaxies, other intelligent civilizations exist, pondering their own existence just as we do. The realization would be breathtaking, shifting our perspective from one of solitude to one of connection and awareness that we are part of a larger cosmic community. However distant and mysterious that community may be, if other civilizations exist, the universe transforms from a silent expanse into a vast, dynamic network of life. We are no longer the singular conscious observers, but participants in a much larger story. The discovery of another intelligent species would fundamentally alter our understanding of biology, evolution, and technology. It would demonstrate that life is not a rare accident, but a natural outcome of the universe's laws of phenomenon that arises wherever conditions permit. Considering other civilizations also raises questions about diversity. Would these beings be carbon-based like us, or something entirely alien? Would they communicate through electromagnetic signals, chemical patterns, or methods beyond our comprehension? The possibilities are endless. Some may have evolved on planets with extreme conditions, developing adaptations we cannot even imagine. Others might be far more technologically advanced, capable of interstellar travel, artificial intelligence integration, or forms of existence that transcend physical bodies altogether. The implications for science are staggering. Discovering extraterrestrial life, particularly intelligent life, would provide an unparalleled opportunity to study evolution and adaptation under radically different conditions. It would allow us to test the universality of physics, chemistry, and biology, seeing how life navigates environments beyond our own. Every interaction, whether direct or inferred through observation, would expand our knowledge of existence and the potential forms intelligence can take. The social and philosophical consequences would also be profound. Humanity would be forced to reconsider its place in the universe, redefining notions of uniqueness, significance, and destiny. Our cultural, ethical, and religious frameworks might adapt to accommodate the reality of other sentient beings. The awareness of other civilizations could foster a sense of humility, but also of connection. As we recognize that consciousness is not confined to Earth alone, communication with extraterrestrial intelligence presents unique challenges. Even at the speed of light, interstellar distances make real-time dialogue impractical across most of the galaxy. Messages could take years, centuries, or even millennia to travel from one star system to another. Civilizations may develop long-term communication strategies, leaving messages encoded in structures, signals, or cosmic artifacts that endure far beyond the lifespan of any individual species. The mere act of attempting contact becomes an exercise in patience, foresight, and imagination on a scale almost unimaginable. Another consideration is the potential behavior of alien civilizations. Some may be benevolent, curious, or collaborative, seeking knowledge and exchange. Others might be indifferent, cautious, or even hostile, acting in ways we cannot predict. The uncertainty of motives introduces a mixture of excitement and caution. Contact with another civilization could herald unprecedented scientific breakthroughs, cultural enrichment, and shared exploration, or it could challenge humanity with risks we have yet to anticipate. Timing is also a crucial factor. The universe is billions of years old, and civilizations may rise and fall long before or after ours. The probability of two intelligent species existing simultaneously and capable of interaction is complex and uncertain. Yet even the potential for such overlap invites reflection on the fleeting and precious nature of life and intelligence. Humanity may be on the verge of encountering others. It may be the first to reach a point of detection and exploration, setting the stage for civilizations yet to emerge. The discovery of life, even microbial, elsewhere would already revolutionize our understanding of biology and chemistry. But intelligent life would redefine the scope of civilization, technology, and culture on a cosmic scale. The confirmation that we are not alone would suggest that intelligence is a natural, perhaps inevitable outcome of evolution, a phenomenon that could spread across galaxies. Our role then shifts from solitary explorers to participants in an interstellar network, capable of learning from and contributing to a universe alive with consciousness. Finally, the awareness that other intelligent life may exist encourages long-term thinking. Our decisions, scientific research, and technological development gain a new dimension of responsibility. Every choice could affect not just humanity, but the potential for peaceful coexistence, mutual understanding, or collaboration with other civilizations. We must approach space exploration, communication, and cultural development with both curiosity and caution, recognizing that we are stepping into a universe that may already be inhabited by minds as capable, or more capable than our own. The realization that we are not alone challenges our assumptions, ignites our imagination, and expands the realm of possibilities. It transforms the universe from a backdrop of stars into a living, interactive stage where life and intelligence may flourish in forms beyond our current comprehension. In acknowledging the potential of other civilizations, humanity embraces a vision of connection, exploration, and responsibility that transcends Earth itself. If we are not alone, the diversity of potential civilizations is likely to be staggering. Scientists often use the Kardashev scale to categorize civilizations based on their energy, usage, and technological sophistication. A Type 1 civilization harnesses all the energy available on its home planet. A Type 2 civilization controls the energy output of its entire star. And a Type 3 civilization manages energy at the scale of an entire galaxy. Humanity is currently just approaching Type 1. But the discovery of civilizations far more advanced could redefine our understanding of technological potential. The existence of advanced civilizations raises questions about longevity. How long do intelligent species survive before succumbing to self-destruction, natural disasters, or cosmic hazards? Some civilizations may have endured for millions or even billions of years, developing technologies and knowledge far beyond our imagination. Others may be short-lived, leaving only fleeting traces in the cosmic record. Understanding these lifespans is critical to assessing the probability, of contact and the nature of the civilizations we might encounter. Technological capabilities of other civilizations could vary widely. Some might communicate via radio waves or light pulses, which we can detect with our instruments. Others may have mastered forms of communication that transcend our comprehension, using neutrinos, gravitational waves, or quantum entanglement. Some may operate through artificial intelligence or consciousness distributed across vast networks, while others might remain biologically based, yet with cognitive capacities far exceeding ours. The possibilities are virtually limitless, constrained only by the laws of physics. The impact of discovering another civilization would extend into human society and culture in profound ways. Philosophical, ethical, and religious frameworks might be challenged, revised, or expanded. The recognition that intelligence is not unique to Earth could foster humility and global unity, highlighting that our differences pale in comparison to the broader context of life in the universe. Conversely, it could also generate fear, competition, or geopolitical tension, especially if the civilization discovered is technologically superior. The question of proximity and detection is crucial. Even if civilizations exist, they may be separated from us by immense distances. Communication might take centuries or millennia to traverse interstellar space. And any contact could be asynchronous, leaving us interpreting signals from a civilization long gone. Despite these challenges, the very possibility of other civilizations encourages the development of new observational methods. From advanced telescopes to space-based sensors, seeking signatures of life, energy consumption, or megastructures across the cosmos, encounters with alien civilizations would not necessarily be direct. We may first detect evidence through indirect means, unusual planetary atmospheres indicating industrial activity, Dyson sphere-like structures capturing stellar energy, or anomalous patterns in electromagnetic signals. Each detection would be a profound confirmation that intelligence has emerged elsewhere, and it would open new avenues of research, imagination, and understanding about life, technology, and the potential futures of consciousness. Speculation about alien civilizations also encourages reflection on cooperation and ethics. If we encounter a civilization far older and more advanced than ours, we must consider principles for peaceful interaction, information exchange, and mutual respect. The responsibility is enormous. Our actions could influence not only our own future, but potentially the trajectory of other intelligences. The ethics of contact, exploration, and even colonization would need to be carefully considered, with humility as a guiding principle. The discovery of intelligent life may also reveal entirely new dimensions of existence. Civilizations could have achieved mastery over time, matter, or energy in ways that challenge our understanding of physics. They might have integrated artificial intelligence or consciousness into collective networks, extending cognitive and experiential capacities far beyond individual limits. Some may have evolved into forms that are incomprehensible to us, existing as digital consciousnesses, energy patterns, or hybrid entities blending biology and technology taught culturally. The realization of other civilizations would expand the human imagination. Literature, art, philosophy, and religion would adapt to accommodate new realities, inspiring visions of interstellar collaboration, communication, and understanding. Science fiction could become an increasingly accurate exploration of potential realities rather than pure imagination. Humanity's stories, values, and identity would be recontextualized within a broader cosmic narrative, where we are participants in a shared network of consciousness. Finally, the awareness of other intelligent life would inspire long-term thinking and interstellar ambition. Humanity would have a model for potential futures, learning from signals, artifacts, or patterns that reveal how civilizations grow, survive, and flourish. Collaboration across space and time could become a goal, fostering unity and purpose. We would be encouraged to cultivate longevity, sustainability, and foresight, recognizing that our trajectory might influence the broader tapestry of life in the universe. In this scenario, the universe is not silent. It is alive with possibility, mystery, and connection. Every star, planet, and galaxy could host forms of intelligence waiting to be discovered. Our exploration, research, and contemplation are steps toward understanding our place in a much larger, interconnected cosmos. If we are not alone, the universe becomes a shared arena of discovery, responsibility, and potential collaboration, a vast stage on which consciousness, in its many forms, coexists and evolves. The prospect of encountering other intelligent civilizations presents both tremendous opportunity and profound uncertainty. If we are not alone, the implications for humanity's future are both exhilarating and daunting. First, consider the opportunities. Knowledge, technology, and cultural exchange could accelerate our understanding of the universe in ways we can scarcely imagine. Civilizations that have survived and thrived for millennia may possess solutions to challenges we have yet to overcome. Energy generation, interstellar travel, even longevity or consciousness preservation. Contact could open a pathway for collaboration, learning, and shared exploration on a scale far beyond our current capabilities. However, alongside opportunity comes risk. The motives of alien civilizations may be inscrutable. We have no guarantee that they would be benevolent, indifferent, or even comprehensible in their goals and ethics. A civilization with superior technology could inadvertently or deliberately pose a threat to humanity. The uncertainty of their intentions highlights the necessity for caution, strategy, and preparedness. Humanity would need to develop both defensive capabilities and diplomatic protocols, balancing curiosity with prudence, so that the search for connection does not expose us to unnecessary danger. The challenges of communication cannot be overstated. Even at light speed, signals may take centuries to traverse interstellar distances. A civilization we detect today may have vanished long ago, leaving only residual evidence of its existence. This temporal disconnect forces humanity to think in unprecedented timeframes, developing long-term strategies for interaction, observation, and record-keeping. Communication may need to be symbolic, mathematical, or encoded in ways designed to endure across vast stretches of space and time, requiring patience and ingenuity on a scale rarely contemplated in human history. Ethical considerations become central in this context. How do we approach a species whose cognitive capacities, moral frameworks, or life experiences are fundamentally different from ours? Interactions with alien life, whether through direct contact, signal exchange, or observation, demand a new form of ethics, one that accounts for intelligence beyond our own. Decisions regarding exploration, interference, or cooperation must be guided by humility, respect, and foresight. Humanity would need to cultivate not only technological sophistication, but also moral maturity, ensuring that our actions do not inadvertently harm or exploit other forms of life. The existence of other civilizations also transforms our understanding of identity. Humanity, once seen as a solitary intelligence in the cosmos, becomes part of a larger, interconnected tapestry of life. We may discover civilizations that have faced existential threats, adapted to extraordinary conditions, or achieved forms of consciousness beyond our comprehension. Learning from them would expand the boundaries of what it means to be intelligent, to exist, and to create. Our sense of purpose would evolve from survival on Earth to participation in a broader cosmic narrative, where exploration, understanding, and cooperation define our trajectory. Culturally, the realization that we are not alone would spark profound transformations. Art, literature, and philosophy would reflect new possibilities, exploring themes of interstellar collaboration, cosmic ethics, and the diversity of life. Education and knowledge systems would expand to include not only the history of humanity, but also the discovery, analysis, and speculation regarding alien civilizations. The very idea of civilization would take on a multi-layered meaning, encompassing both terrestrial achievements and potential interstellar connections. Space exploration would gain unprecedented urgency and purpose. Beyond national or economic motives, humanity would embark on interstellar travel as a quest for understanding, dialogue, and coexistence. The universe itself becomes a network to navigate, a canvas for discovery, and a playground for curiosity. Our mission would not be merely survival, but engagement, learning from other civilizations, sharing our knowledge, and contributing to a collective understanding of existence. Technological advancement would accelerate in response to this new reality. The possibility of encountering more advanced civilizations would inspire leaps in communication, energy harnessing, propulsion, and artificial intelligence. Humanity would be challenged to push the boundaries of physics, engineering, and cognitive understanding, striving to bridge the gap between our current capabilities and those of civilizations that have potentially existed for millions of years. The drive to survive, communicate, and explore would catalyze innovation on an unprecedented scale. Ultimately, the awareness that we are not alone transforms the human story. Solitude gives way to connection, and the universe becomes a community, even if distant and fragmented. Humanity would need to cultivate patience, ethics, and creativity, embracing the unknown, not with fear alone, but with curiosity and responsibility. Every choice, scientific, cultural, technological, or ethical, would carry consequences beyond our planet, shaping the legacy of consciousness itself. In the end, whether we are alone or not, the cosmos challenges us to reflect on our nature, potential, and purpose. If other civilizations exist, the universe becomes an arena of opportunity, risk, and collaboration, a stage on which humanity can learn, grow, and engage with minds both familiar and alien. The stars are no longer simply distant lights. They are destinations, beacons, and possible homes for knowledge, life, and connection. Our place in the cosmos, once defined by isolation, is redefined as part of a broader narrative of intelligence, discovery, and shared existence. The search for extraterrestrial life is one of humanity's most profound scientific endeavors. It is a pursuit that stretches the limits of imagination, technology, and patience, motivated by the simple yet monumental question, are we alone? From ancient stargazers to modern astrophysicists, humans have long looked to the heavens, pondering whether life exists beyond Earth. Today, our efforts are more systematic, relying on sophisticated instruments, space missions, and theoretical models to identify signs of life across the galaxy. One of the first strategies in this quest is the detection of biosignatures, chemical or physical indicators of life. On planets and moons within our solar system, scientists search for evidence of water, organic molecules, and atmospheric compounds such as oxygen or methane, which could suggest biological activity. For example, the icy moons of Jupiter and Saturn, like Europa and Enceladus, harbor subsurface oceans that might support microbial life. Even tiny chemical imbalances in these environments can provide critical clues that life may exist in hidden pockets beneath their frozen surfaces beyond our solar system. The focus shifts to planets orbiting distant stars. With thousands of exoplanets now identified, astronomers classify them according to size, composition, and location within the habitable zone, the range of distances from a star where liquid water could exist. Using advanced telescopes, we analyze the light from these planets, searching for chemical fingerprints in their atmospheres. This technique, called spectroscopy, allows us to detect molecules that may indicate biological processes such as oxygen, ozone, or methane. Even across light years of space, the search is not limited to detecting life as we know it. Scientists are also considering alternative biochemistries, life forms that could arise under conditions very different from Earth's. For instance, life might exist in environments rich in ammonia, methane, or sulfur, thriving where liquid water is scarce. Such possibilities expand our understanding of what it means to be habitable and ensure that the search for life does not overlook forms of life radically different from our own. Another promising avenue is the search for technosignatures, evidence of advanced civilizations. Unlike simple biosignatures, technosignatures indicate intelligent activity, such as radio signals, laser emissions, or large-scale structures like Dyson spheres that could harness a star's energy. Projects such as SETI search for extraterrestrial intelligence, scan the sky for patterns that could not be produced by natural astrophysical processes. The detection of such a signal would instantly transform our understanding of life in the universe and place humanity within a network of other intelligences. Space missions have also played a critical role in this search. Robotic explorers, landers, and orbiters have provided detailed data on planetary surfaces, atmospheres, and subsurface environments. Mars rovers, for example, have discovered ancient riverbeds, organic molecules, and seasonal methane fluctuations, fueling speculation about past or present microbial life. Future missions aim to drill beneath icy crusts, capture samples, and return them to Earth for detailed analysis, increasing our chances of direct detection. The search for extraterrestrial life is as much about patience and persistence as it is about technology. Signals from distant stars may take decades, centuries, or millennia to reach us. The universe is vast, and the number of potential habitats is enormous. Therefore, scientists employ statistical models, probability calculations, case simulation techniques to prioritize targets, estimate likelihoods of life, and refine observational strategies. These efforts provide structure to a quest that could otherwise seem overwhelming given the sheer scale of the cosmos. Collaborative efforts amplify the search's effectiveness. International observatories, space agencies, and research institutions pool resources, expertise, and data, creating a global network of exploration. Citizen science initiatives allow the public to participate in scanning data for unusual signals or patterns, expanding the reach of professional research. By combining technology, collaboration, and imagination, humanity maximizes its chances of answering one of the most fundamental questions ever asked: are we alone? Or is life a cosmic phenomenon that flourishes elsewhere? Finally, the search for life is inseparable from our philosophical reflections. Every new discovery, whether it is a promising exoplanet, a subsurface ocean, or an unusual chemical signature, invites contemplation about humanity's place in the universe. Finding life, microbial or intelligent, would provide perspective on our uniqueness, resilience, and the processes that lead to consciousness. The search itself even in the absence of definitive evidence, shapes our understanding of existence, encouraging humility, curiosity, and wonder. Advancing beyond basic observation, humanity employs increasingly sophisticated techniques to detect life across the cosmos. Modern astronomy and space science combine multiple approaches, from high-precision telescopes to robotic explorers, allowing us to explore environments previously inaccessible. One of the most powerful tools in this effort is the Space Telescope, designed to observe distant stars and planets with unparalleled clarity. Instruments like the James Webb Space Telescope can analyze starlight filtered through planetary atmospheres, revealing subtle spectral fingerprints that may indicate the presence of oxygen, water vapor, methane, or other molecules associated with biological activity. Another critical technique is radio astronomy, used extensively in the search for intelligent life. Radio waves travel vast distances with minimal interference, making them ideal for detecting potential communications from distant civilizations. Organizations like SETI monitor millions of star systems for signals that differ from natural cosmic noise. Even faint or irregular patterns can be scrutinized for signs of artificial origin, opening a window into civilizations that may have existed hundreds or thousands of light years away, in addition to electromagnetic signals. Scientists are exploring technosignatures beyond traditional radio waves. Laser emissions, neutrino bursts, or megastructures. Hypothetical constructs like Dyson spheres that capture a star's energy could reveal the presence of advanced civilizations. These technosignatures allow researchers to search not only for life, but also for intelligence, highlighting the difference between mere biological existence and civilizations capable of manipulating energy and technology. On a grand scale, within our solar system, robotic exploration continues to be indispensable. Landers and rovers on Mars, as well as orbiters circling Jupiter and Saturn, provide detailed data on surface conditions, its chemical compositions, and potential habitats. The icy moons Europa and Enceladus are particularly compelling. Subsurface oceans beneath their frozen crusts could harbor microbial life. Scientists plan future missions to drill beneath these surfaces, collect samples, and analyze them directly, offering the most tangible way to detect life beyond Earth. Theoretical modeling also plays a central role in the search. Astrobiologists and physicists simulate planetary environments, chemical processes, and evolutionary scenarios to predict where life is most likely to arise. These models guide observational priorities, helping scientists focus on planets within the habitable zone with suitable temperatures, atmospheres, and chemical compositions. By combining observation with simulation, humanity increases the efficiency and probability of detecting life in the vastness of space. Exoplanet studies have revolutionized our understanding of potentially habitable worlds. Thousands of exoplanets have been discovered in recent decades, ranging from rocky Earth-like planets to gas giants. Within this immense variety, some exoplanets orbit in the Goldilocks zone, where temperatures allow for liquid water. Observing these planets, scientists look for atmospheric anomalies, seasonal variations, or chemical imbalances that may indicate biological processes. Even minute deviations from expected norms can signal life, making every observation a potential breakthrough. Beyond technology and observation, the search for extraterrestrial life requires a profound understanding of what life could be. Life may not mirror terrestrial biology. It could thrive in extreme conditions, exist in forms unlike anything we know, or employ chemistry entirely alien to Earth. Researchers study extremophiles, on-our-planet organisms that survive in boiling acid, deep ocean trenches, or radioactive environments to expand the possible conditions in which life might emerge elsewhere. These studies redefine habitability and ensure our search is not limited by narrow assumptions. The search for life is inherently interdisciplinary. It draws upon astronomy, biology, chemistry, geology, and physics, blending empirical observation with theoretical speculation. Astrobiology, in particular, serves as the nexus of these fields, examining the origins, evolution, and potential distribution of life in the universe. By combining knowledge of Earth's life forms with cosmic observations, scientists build a framework for predicting where and how life could exist beyond our planet. Ultimately, the search for extraterrestrial life is both a scientific mission and a philosophical journey. Each experiment, observation, and discovery challenges humanity to consider the broader context of existence. The detection of even the simplest microbial life would profoundly affect our understanding of biology and evolution, demonstrating that life is not unique to Earth. The discovery of intelligent life would further transform society, science, and culture, reshaping our concept of civilization, ethics, and the potential for interstellar collaboration donned in the grand scheme. These efforts remind us that humanity is not just a passive observer, but an active participant in the cosmic story. Every telescope trained on distant stars, every probe sent to icy moons, and every model of exoplanetary environments represents a step toward answering the question that has captivated humankind for centuries. Are we alone, or is the universe teeming with life? Looking toward the future, humanity's search for extraterrestrial life is poised to enter a new era of exploration and discovery. Upcoming space missions, technological innovations, and international collaborations promise to expand our reach and deepen our understanding of potential life beyond Earth. Among the most ambitious plans are missions designed to directly sample environments where life could exist, such as the subsurface oceans of icy moons and the soil and atmosphere of distant exoplanets. For instance, NASA and ESA have proposed missions to Europa, aiming to penetrate its icy crust and investigate the ocean below. Similarly, missions to Enceladus focus on analyzing plumes of water vapor ejected into space, which may contain organic compounds or microbial life. These missions represent the closest humanity can come to directly observing extraterrestrial life without leaving the solar system. Every sample analyzed, every chemical signature detected, could redefine our understanding of life's resilience and adaptability. Advances in telescope technology also promise unprecedented capabilities. Instruments like the James Webb Space Telescope and the proposed LOVOIR Large UV Optical Infrared Surveyor can detect atmospheric and surface signatures of exoplanets hundreds of light-years away by analyzing spectra for biosignatures or chemical anomalies. These telescopes act as cosmic microscopes, allowing humanity to study alien worlds without physically traveling to them. Future telescopes may also detect technosignatures, identifying energy usage, artificial light, or patterns that indicate the presence of advanced civilizations. Interstellar exploration remains a long-term challenge, but projects such as Breakthrough Starshot aim to send tiny, laser-propelled probes to nearby star systems at a fraction of the speed of light, while still in conceptual stages. Such projects could allow us to gather data on exoplanets and neighboring systems within decades rather than centuries. Even small probes could capture invaluable images, atmospheric data, and other measurements, providing humanity with a direct glimpse of alien worlds and potential habitats for life. Another critical avenue is the development of advanced artificial intelligence systems to assist in the search. AI can process vast amounts of data from telescopes, probes, and satellites, identifying anomalies or patterns that might otherwise go unnoticed. Machine learning algorithms can detect subtle spectral signatures, track unusual light fluctuations, or recognize potential signals from intelligent life. By augmenting human observation with AI, we dramatically increase our chances of detecting evidence of life and interpreting complex data sets across the universe. Collaboration across nations and disciplines is equally essential. The search for extraterrestrial life transcends borders, cultures, and politics. International efforts allow pooling of resources, expertise, and technology, while citizen science projects enable millions of people to participate. Initiatives like SETI at Home, where volunteers analyze radio signals from space, demonstrate how collective effort can enhance the scope of exploration and foster global curiosity about life beyond Earth. Even as we expand our search, we must prepare for the philosophical and societal implications of discovery. Detecting life, whether microbial or intelligent, will challenge assumptions about humanity's uniqueness and our place in the cosmos. It will inspire new philosophies, reshape cultural narratives, and spark debates about ethics, communication, and collaboration with life forms that may be profoundly different from us. Scientists and policymakers must be ready to respond responsibly, balancing excitement with caution and curiosity with prudence. The search for extraterrestrial life also highlights the urgency of preserving our own planet. Earth is, for now, the only confirmed cradle of life we know. Studying life elsewhere reinforces the fragility and rarity of habitable environments, underscoring the importance of sustainability, environmental stewardship, and global cooperation. Understanding life's potential elsewhere gives humanity both perspective and motivation, a cosmic reminder that life, in all its forms, is precious and worth protecting. Finally, the very act of searching transforms humanity's relationship with the cosmos. Gazing at distant stars and planets becomes an exploration of identity, purpose, and possibility. Each mission, observation, and model reflects our drive to understand not only the universe, but ourselves. The search for extraterrestrial life is a testament to curiosity, ingenuity, and pursuit that unites science, philosophy, and imagination in the timeless quest to know whether we share the cosmos with others. In the end, whether or not we discover life in the near future, the search itself enriches humanity. It teaches patience, fosters collaboration, and fuels wonder. It challenges us to expand our definitions of life, intelligence, and civilization. And perhaps, most importantly, it reminds us that the universe is vast, mysterious, and alive with potential an endless frontier for exploration, discovery, and the profound realization that we may not be alone after all. The universe is not static, nor is our understanding of it. As we look toward the future of cosmology, we find ourselves standing at the edge of profound discovery. The questions we ask today about dark matter, dark energy, the origin of the cosmos, and the ultimate fate of everything will shape the next century of science. Humanity's capacity to peer deeper into the fabric of reality has never been greater, and the coming decades will likely redefine how we think about existence itself. One of the greatest frontiers in cosmology is the mystery of dark matter. Observations of galaxies revealed that visible matter, stars, gas, planets, accounts for only a small fraction of what exists. The rest appears as an invisible, gravitationally influential substance we cannot yet see or touch. Despite decades of searching, dark matter remains elusive. Future detectors built deep underground or orbiting high above Earth may one day catch direct interactions of dark matter particles. If confirmed, this would revolutionize physics, providing a new understanding of the building blocks of reality and revealing hidden structures that have shaped the cosmos since its birth. Closely related is the enigma of dark energy, a force driving the accelerated expansion of the universe. While dark matter binds galaxies together, dark energy pushes them apart. Current measurements suggest that nearly 70% of the universe is made of this mysterious energy. Yet we know almost nothing about it. In the future, next-generation telescopes like the Nancy Grace Roman Space Telescope and the Euclid mission will map the Euclid-scale structure of the cosmos with exquisite precision. By studying how galaxies cluster and how cosmic expansion has changed over time, cosmologists may uncover the true nature of dark energy. Whether it is a constant property of space or a dynamic field that evolves with time, The pursuit of a unified theory of physics also lies at the heart of cosmology's future. Today, physics is divided. General relativity describes gravity and the cosmic scale, while quantum mechanics governs the subatomic realm. Bridging these two frameworks, a challenge known as quantum gravity could unlock answers to some of the most profound questions. What happened before the Big Bang? What lies inside a black hole? And does space-time itself emerge from something more fundamental? Theoretical work, combined with experiments at particle accelerators and astronomical observations of black holes and gravitational waves, may one day lead to a framework that unites the very large and the very small. Gravitational wave astronomy is another revolutionary field poised to expand. With instruments like LIGO, Virgo, and CAGRA, scientists can now listen to the ripples in spacetime produced by colliding black holes and neutron stars. In the future, space-based observatories such as LISA Laser Interferometer Space Antenna will extend this capability, detecting lower frequency gravitational waves that reveal mergers of supermassive black holes and possibly even signals from the early universe itself. These observations open a new window into cosmic history, allowing us to study events otherwise invisible to telescopes that rely on light. Cosmology's future also rests on humanity's ability to see further back in time. The cosmic microwave background, the faint afterglow of the Big Bang, has already provided clues about the early universe. Yet new missions could map this radiation with even greater precision, revealing hints of cosmic inflation, the rapid expansion thought to have occurred in the universe's first moments. If inflation is confirmed, it would profoundly reshape our understanding of the cosmos, suggesting that our universe may be just one of many in a vast multiverse. Such a revelation would carry not only scientific weight, but also deep philosophical consequences, challenging the uniqueness of our cosmic home. As technology advances, we may also approach the question of the universe's ultimate fate. Will expansion continue forever, leaving a cold, dark cosmos devoid of stars and galaxies? Will it reverse into a collapse, ending in a fiery Big Crunch? Or will it fragment into new universes, each with different physical laws, in a perpetual cycle of creation? Observations of cosmic expansion, dark energy, and high-energy phenomena may eventually point us toward one of these futures, offering a glimpse into the destiny of all existence. The future of cosmology is not only about discovering answers, but also about confronting limits. There may be horizons we can never cross, scales of reality forever hidden, or phenomena beyond our capacity to observe. Yet even these limits can inspire new creativity. As scientists develop novel tools and bold theories to probe the boundaries of the knowable. In this sense, cosmology is as much a human story as it is a scientific one. It reflects our enduring drive to seek meaning, to push past ignorance, and to understand our place in the vastness of creation. And so, as we look ahead, the future of cosmology appears as both a challenge and a promise. It promises breakthroughs that could redefine existence itself, but it also challenges us to remain humble in the face of the unknown. For every discovery, new mysteries will arise, ensuring that the cosmic journey never truly ends. As we consider the path forward, one of the defining elements of cosmology's future will be the instruments we build to extend our vision. Each generation of telescopes has transformed our understanding of the universe, and the next wave promises to push us even further. The extremely large telescope ELT, currently under construction in Chile, will feature a mirror nearly 40 meters across, capable of resolving details never before seen on distant galaxies and exoplanets. Similarly, the 30-meter telescope and the Giant Magellan Telescope will provide complementary capabilities, allowing astronomers to probe deeper into cosmic history and search for faint signatures of life across distant worlds. But ground-based observatories are only part of the picture. In space, we anticipate missions like LOVEWAR and HABEX, designed to directly image Earth-like exoplanets and analyze their atmospheres for signs of habitability. These telescopes, coupled with advances in coronagraphs and starshades, could isolate planetary light from the overwhelming glare of their parent stars, offering us our first clear glimpses of alien worlds that might resemble our own. With such data, cosmology shifts from theoretical speculation to direct empirical discovery, moving us closer to answering the age-old question: are we alone? Artificial intelligence will also play a crucial role. The sheer volume of data generated by future observatories will far exceed human capacity to process. AI systems trained to recognize patterns, classify galaxies, identify anomalies, and even hypothesize explanations will act as co-pilots in discovery. Already, machine learning is identifying new exoplanets and flagging unusual signals in telescope data. In the future, AI could uncover phenomena humans would never think to search for, effectively expanding the boundaries of imagination itself. Cosmology, in this sense, becomes a partnership not just between nations and institutions, but between human intuition and artificial cognition. Meanwhile, cosmology is increasingly intertwined with particle physics and laboratory science. Experiments at facilities like CERN's Large Hadron Collider continue to explore the fundamental building blocks of reality by recreating conditions similar to those present in the early universe. Physicists test models of cosmic evolution, dark matter, and extra dimensions. The synergy between cosmological observation and particle experimentation means that discoveries in one realm often reverberate across the other. A particle detected underground could solve puzzles about galaxy formation, while astronomical data could point to new particles yet unseen in accelerators. Human space exploration will also shape cosmology's future, as astronauts return to the Moon and prepare for missions to Mars. The infrastructure developed for these endeavors, powerful rockets, deep space communication networks, and long-term habitats will support broader cosmological projects. Establishing observatories on the far side of the Moon, shielded from Earth's radio noise, could create pristine environments for radio astronomy. Crewed missions to the outer solar system, though decades away, could deploy instruments to directly study phenomena beyond Earth's reach, such as interstellar space. Another frontier is the study of cosmic phenomena in real time. As instruments become more sensitive and networks of telescopes coordinate globally, we can observe transient events, supernova, Gamma bursts, or neutron star collisions as they unfold. These events not only provide spectacular views, but also serve as laboratories for extreme physics, testing theories of relativity, nuclear matter, and the behavior of the universe under its most violent conditions. Real-time cosmology allows humanity to watch the universe not as a static backdrop, but as a dynamic, evolving system beyond practical science. The future of cosmology may fundamentally shift our sense of scale. The concept of a multiverse, once confined to theoretical speculation, is gaining traction as cosmologists grapple with the fine-tuning of our universe. Why does physics permit the existence of life at all? Why do the constants of nature fall within such narrow ranges? One possible answer is that our universe is but one of countless others, each with different laws of physics, most sterile, a few hospitable. While proving the multiverse may be beyond empirical reach, indirect evidence through inflation theory, string theory, or subtle patterns in the cosmic microwave background could lend weight to the idea, opening perhaps the most profound philosophical debate of all time. Cosmology's future is also deeply tied to communication. Discoveries must not only be made, but shared in ways that inspire, educate, and unify. As cosmology becomes more complex, bridging the gap between experts and the public will be vital. The more humanity understands about the cosmos, the more we appreciate its beauty, fragility, and mystery. Popular science, educational platforms, and immersive technologies like virtual reality could bring the universe closer to people everywhere. transforming cosmology from a field of study into a shared human experience. Ultimately, the tools and methods of future cosmology are about more than data. They represent humanity's determination to transcend limits of sight, of thought, of distance. Each innovation, from giant telescopes to quantum computers, reflects a deeper truth, that the universe is vast, but our curiosity is vaster still. The coming decades promise not only answers to questions we have long asked, but questions we have not yet imagined, ensuring that the pursuit of cosmology remains an infinite, evolving dialogue between the cosmos and the human spirit. Looking further ahead, the future of cosmology begins to blur the line between science and speculation, between the measurable and the philosophical. Some questions may remain forever beyond empirical proof, yet they still drive inquiry, creativity, and wonder. As technology advances and imagination expands, cosmology may push us toward horizons where human identity itself is reshaped. One bold prospect lies in interstellar probes and megastructures. Today's concepts, like breakthrough starshot, sending wafer-thin sails propelled by lasers to nearby stars, are small beginnings. A more advanced civilization, perhaps even our distant descendants, might deploy fleets of interstellar observatories, or construct Dyson-like structures to harness stellar energy and study the universe with godlike precision. Such engineering marvels, while far beyond current capability, are not forbidden by physics. If realized, they would transform cosmology into a direct exploration, allowing us to map galaxies up close rather than from afar. Another frontier is cosmic simulation theory. Some philosophers and physicists suggest that our universe itself could be a kind of simulation, a construct of higher-order intelligence, or perhaps even an inevitable emergent phenomenon of computation at scale. Though difficult to test, this idea raises profound cosmological questions. If reality is simulated, what lies outside it? Could clues be embedded in the laws of physics themselves? Irregularities in cosmic background radiation, for instance, or limits on computational resolution. While controversial, the notion compels us to reflect on the deepest level of cosmology, not only the structure of the universe, but the nature of existence itself. The ultimate fate of the universe remains perhaps the most poignant mystery of all. Observations today suggest that the cosmos will continue expanding, galaxies drifting farther apart until the night sky grows empty, stars burn out, and only cold embers remain. This vision of a heat death is haunting, a silent universe where time stretches into infinity, with no structures left to carry memory or meaning. Yet other possibilities remain on the table. Perhaps dark energy is unstable, leading one day to a reversal of expansion, a big crunch where everything collapses back into a singularity. Or perhaps the universe undergoes cycles, endlessly reborn in a big bounce, each cosmos leaving faint imprints on the next. Each scenario reframes cosmology not just as a study of beginnings, but of endings. And each carries implications for how we understand permanence, purpose, and hope. In considering these fates, cosmology becomes inseparable from human meaning. If the universe will eventually grow dark and cold, does that diminish our significance, or does it make our fleeting moment of consciousness infinitely more precious? If countless universes exist, each with different rules, does that reduce ours to insignificance, or elevate it as one unique thread in an infinite tapestry? These are not merely scientific questions, they are existential ones, where cosmology intersects with philosophy, spirituality, and art. Cosmology may also drive a shift in human self-perception. As we uncover more about the universe's origins, contents, and destiny, we may come to see ourselves not as isolated beings on a pale blue dot, but as active participants in a cosmic story. Perhaps our role is to preserve life, to spread consciousness, or even to shape the universe itself through technology and discovery. In this sense, the future of cosmology is not only about knowing the cosmos, but deciding how humanity fits within it. The integration of cosmology, with human culture is inevitable. As new discoveries unfold, they will influence literature, music, visual art, and spiritual traditions. They will spark debates about what it means to be alive in a universe where life may be rare or abundant, fragile or eternal. Just as ancient cosmologies shaped civilizations, so too will modern cosmology guide future societies, offering myths not of gods and heroes, but of galaxies, quantum fields, and cosmic evolution. Its most speculative edge. Cosmology could even inform the future trajectory of human evolution. If we survive long enough to become an interstellar species, our identity may become inseparable from the cosmos itself. Future humans might adapt biologically or technologically to live among the stars, drawing energy from black holes, building civilizations around nebulae, or even transcending physical form altogether. Cosmology in that era would not be an external field of study, but the very environment of life. The universe, once an object of contemplation, would become home. And yet, even amid speculation, one truth persists: the universe will always exceed our grasp. There will always be horizons too distant, mysteries too deep, scales too vast. But perhaps that is what makes cosmology endlessly meaningful. Its future lies not in final answers, but in perpetual questions, each discovery a doorway to new wonder. Each revelation a reminder that existence is richer than we can ever fully know. In this sense, the future of cosmology mirrors the future of humanity. Both are journeys into the unknown, fueled by curiosity, guided by reason, and animated by wonder. Whether we remain confined to Earth or scatter among the stars, whether the universe ends in fire or fades into silence, our quest to understand it is itself a triumph proof that consciousness, however brief, can reach across the void and touch infinity. As the search for extraterrestrial life continues into the future, one of the most fascinating aspects is how it forces humanity to look both outward and inward. Outward into the endless skies, probing galaxies far beyond our reach, hoping to find even the faintest hint of life's presence. Inward into our own origins, values, and destiny. As we reflect on what discovering others like us, or profoundly unlike us, would truly mean, the search itself is no longer a fringe pursuit. It has become one of the defining questions of modern science. It bridges astronomy, biology, chemistry, and even philosophy. When telescopes scan the cosmos for biosignatures, they are not just searching for oxygen, methane, or water vapor. They are asking whether life is an inevitable outcome of physics and chemistry, or a rare miracle confined to Earth. Looking at the trajectory of our search so far, 'tis clear that humanity has moved from myth to data. Ancient civilizations once told stories of gods, spirits, and celestial beings inhabiting the skies. Today, astronomers use instruments capable of detecting the faint wobble of a planet hundreds of light years away, or the dimming of a star's light as a world crosses in front of it. Each discovery pushes the boundaries of what we know, showing us how many worlds are possibly beyond, reminding us that Earth is only one among billions. Perhaps the most intriguing element of the search is how it shapes human imagination. Even without evidence of alien civilizations, our stories, whether in literature, film, or scientific speculation, fill the void. They serve as mirrors of our fears and hopes. The idea of extraterrestrials has been portrayed as threatening invaders, benevolent guides, indifferent observers, or beings so advanced that we cannot comprehend their existence. Each vision tells us as much about ourselves as it does about the universe. At the same time, the search teaches humility. The cosmos is vast, and our technology, though advancing rapidly, is still limited. We may not find clear evidence of life for decades or centuries. Yet the pursuit itself is valuable because it drives innovation, curiosity, and unity. Each mission to Mars, each telescope launch, each radio signal sent toward the stars reflects our refusal to remain passive in the face of the unknown. Some scientists argue that the first true evidence of life will come not from intelligent civilizations, but from microbes. A fossilized bacterium on Mars or chemical signatures in the clouds of Venus could revolutionize our understanding. If life is found twice within a single solar system, the conclusion becomes inescapable. The universe is teeming with life. On the other hand, if even the simplest organisms elude us, the silence will raise profound questions about whether intelligence is an impossibility rather than a likelihood. The search also intersects with the question of human destiny. If we are alone, then we carry the unique responsibility of ensuring that life continues to exist in the universe. If we are not alone, then we must consider what kind of civilization we want to be when we finally make contact. Will we be explorers, ambassadors, or conquerors? Will we fear the other, or will we extend a hand across the void? These questions are not science fiction. They are ethical, cultural, and philosophical challenges waiting in the near or distant future. Perhaps the greatest value of the search is that it binds humanity together under a shared mystery. No matter where someone is born, what language they speak, or what beliefs they hold, the night sky belongs to everyone. The possibility that we are part of a much larger community of life, for even that we stand alone as the singular conscious flame in a dark universe, transcends all borders and divisions. And so, humanity continues to listen, to search, to hope. The sky remains silent, but silence itself is not the end of the story. It is the beginning. Every unanswered question is an invitation to keep going. Every faint signal, every distant world discovered, every experiment designed to probe the unknown is part of a collective journey. The search for extraterrestrial life is, ultimately, a search for meaning. In looking outward, we redefine what it means to be human. Whether the answer is solitude or company, fragility or resilience, we will find ourselves changed by the journey. And perhaps that is the most important truth. The quest is not only about who might be out there, but about who we become while searching. When people speak of humanity's future among the stars, it is easy to fall into one of two traps: wild optimism or crushing skepticism. On the one hand, science fiction paints us as a spacefaring civilization, colonizing planets, building megastructures, and traveling across interstellar distances. On the other, the immense technical challenges of surviving beyond Earth radiation, distance, resource scarcity, make such visions seem impossible. Yet the truth likely lies in a middle ground. Progress will be slower than the boldest predictions, but faster than the most cynical dismissals. The first step in humanity's cosmic future is survival. Our species has existed for roughly 300,000 years. But only in the last few centuries have we acquired the power to destroy ourselves through nuclear war, ecological collapse, or technological mismanagement. If humanity cannot navigate the next few hundred years wisely, then dreams of interstellar travel will never matter. The future in the cosmos begins with protecting our home planet, ensuring that Earth remains livable, and using it as a springboard rather than a cautionary tale. Yet assuming we manage to avoid catastrophe, the next century will likely see humanity expand further into our solar system. The Moon and Mars are the most obvious targets. The Moon offers proximity, a testing ground only a few days away. Mars offers the tantalizing promise of being Earth-like enough to sustain colonies. If we can overcome its thin atmosphere, low gravity, and frigid climate, neither will be easy. But both provide opportunities to learn what it means to live on worlds other than our own. This stage turning humanity into a multiplanetary species may unfold. Over the next 100 to 200 years, colonies will begin as fragile outposts dependent on Earth for supplies, technology, and expertise. But if they survive, they will grow into self-sufficient societies, experimenting with new political systems, economies, and cultures shaped by their alien environments. History suggests that distance breeds diversity. Just as continents on Earth produced distinct civilizations, so too may the Moon, Mars, and beyond cultivate cultures different from our own. The long-term vision often includes terraforming, reshaping planets to be more Earth-like. Mars, with its CO atmosphere, seems a candidate, though the scale of engineering required is staggering. To heat a planet, thicken its atmosphere, and produce breathable air is not a project of decades, but of millennia. Yet humanity has already shown the ability to alter an entire planet unintentionally through climate change. The question is whether we could learn to do so deliberately and responsibly. Beyond Mars, attention turns to the outer solar system. The icy moons of Jupiter and Saturn, Europa, Ganymede, and Enceladus, Titan contain vast oceans beneath their frozen crusts. These may not only be places to live, but places where life might already exist. Colonies here would be even more challenging. But they would also expand humanity's presence into environments profoundly different from Earth. Titan, with its thick nitrogen atmosphere and seas of liquid methane, could one day host floating cities as humanity spreads. The question of governance becomes critical. Will colonies remain tied to Earth, subject to its laws and politics? Or will they declare independence, as colonies on Earth have done throughout history? The balance between unity and freedom, cooperation and autonomy, may determine whether the future of humanity is harmonious or fractured. Spacefaring civilization could either unify under shared goals or splinter into competing factions scattered across the stars. Technology will be the great enabler of this expansion. Advances in artificial intelligence, robotics, biotechnology, and energy production will determine whether life beyond Earth is sustainable. Self-replicating machines may construct habitats on distant worlds before humans arrive. Genetic engineering could adapt our biology to harsh environments. Fusion power, if achieved, could provide the energy needed for terraforming and interstellar propulsion. Each breakthrough will open doors that today seem locked, but perhaps the most profound question is not how far we go, but why we go. Exploration has always been part of the human story, but it has also been driven by necessity's scarcity of land, resources, or opportunity. If humanity thrives on Earth, will the stars still call to us? Or will only desperation, climate crisis, overpopulation, dwindling resources push us outward? The motivation behind expansion may shape its ethics. A civilization that goes into space for profit or survival may act differently than one that goes in search of knowledge, meaning, or beauty. The 1,000-year horizon forces us to think long-term in ways we rarely do. Our politics is shaped by years, our businesses by quarters, our lives by decades. But the cosmos demands patience. Civilizations that endure for millennia must learn to think in centuries, to plant seeds that may not bear fruit until long after their founders are gone. This shift in mindset may be the hardest challenge of all, and yet the promise is extraordinary. To imagine humanity not confined to one fragile planet, but spread across many worlds, is to imagine resilience. Disasters on Earth would no longer threaten extinction. New cultures, new arts, new sciences could emerge in alien skies. We would not just be Earthlings, we would be a cosmic species in this vision. The future of humanity in the cosmos is not just about survival, but about flourishing. It is about carrying forward the best of what we are, our creativity, our curiosity, our capacity for wonder while leaving behind the worst our conflicts, our short-sightedness, our destruction. Whether we succeed will depend not only on rockets and machines, but on wisdom. The journey into the cosmos is not guaranteed. It is a possibility, fragile and uncertain, but one that lies within our grasp. And that, perhaps, is what makes it so compelling. The stars do not promise us a future, but they offer us the chance to create one. If the first stage of humanity's future is the colonization of our own solar system, The second is the leap beyond it. This is where dreams often collide with the hard wall of physics. The nearest star system, Alpha Centauri, is over 4 light-years away. At the speeds of our fastest spacecraft today, it would take tens of thousands of years to arrive. And yet, the possibility of bridging that vast gulf is what transforms humanity from a planetary or solar civilization into a truly interstellar one. The challenge begins with propulsion. Chemical rockets, the engines that carried us to the moon and power most space missions, are woefully inadequate for interstellar travel. To reach even a fraction of the speed of light, new technologies are required. Proposals range from nuclear fusion rock, harnessing the same reaction that powers the sun, to antimatter drives, which could unleash immense energy by annihilating particles and antiparticles. Others imagine vast solar sails pushed by beams of light, riding photons across interstellar space like ships catching wind. Some of these technologies may remain theoretical for centuries, but others are already being tested in small ways. The Breakthrough Starshot Initiative, for example, envisions sending tiny probes propelled by powerful lasers to Alpha Centauri at 20% the speed of light, arriving in just a few decades. These probes would be no larger than a chip, but they represent a proof of concept that interstellar travel, even if unmanned at first, is not beyond imagination. Yet interstellar travel is not only a technical challenge, it is a cultural one. Imagine a generation ship, a vast vessel carrying thousands of people on a journey lasting hundreds or thousands of years. Those who depart will never see the destination. Only their descendants will. A society born on such a ship would be shaped not by Earth or its history, but by the closed world of their vessel. Would they maintain the mission, or would their priorities shift? Could they preserve knowledge, culture, and purpose across centuries of isolation? These questions are as important as any question of engineering. There are alternatives. If we develop the ability to extend human lifespans dramatically through biotechnology or digital consciousness transfer, interstellar voyages may be experienced by the same individuals who begin them. The prospect of uploading human minds into machines sending consciousness as streams of data rather than fragile biological bodies has become a serious topic of speculation. If intelligence can exist without the limitations of flesh, then the stars might not be so distant after all. But even if interstellar travel is achieved, what awaits us? Astronomers have already discovered thousands of exoplanets, some in the habitable zones of their stars, where liquid water could exist. Many of these worlds are likely barren rocks, but some may be Earth-like. The thought of standing on an alien shore under a foreign sun, with skies shaped by a different chemistry, is almost overwhelming. These would not just be new homes, but entirely new canvases for human imagination. Still, interstellar colonization is not just about finding new Earths. In fact, Earth-like planets may be rare, and adapting them to human needs may be harder than building artificial habitats. Many thinkers imagine humanity spreading not by settling planets, but by constructing vast space stations, rotating cylinders that simulate gravity, powered by nearby stars, capable of sustaining entire civilizations. Such habitats could, in theory, be built anywhere, around any star, using the materials of asteroids and moons. If so, the future of humanity may not be tied to planets at all, but to structures of our own design. On the grandest scale, some envision Dyson spheres or swarms, networks of satellites that capture the total energy output of a star. Such megastructures would transform a civilization's power supply, allowing it to grow orders of magnitude beyond our current limits. Astronomers even search for signs of such constructs in distant galaxies, wondering whether unusual dimming patterns might betray the presence of alien engineering. If humanity survives long enough, the question is not whether such projects are possible, but whether they are desirable and whether they are inevitable. The further humanity spreads, the stranger our descendants may become. Evolution will not stop, and with the aid of genetic engineering, directed evolution will accelerate. Colonies on worlds with lower gravity may produce taller, more slender humans. Those in high radiation environments may develop or engineer themselves to resist it. Some may merge with machines so fully that they no longer resemble the humans of Earth. The idea of humanity may expand beyond recognition, encompassing a family of species adapted to countless environments. This raises a profound question. Will all these diverse branches of humanity remain connected? Will they see themselves as one civilization or many? Language, culture, and biology may diverge so far that mutual understanding becomes difficult. The cosmos may not produce a unified humanity, but a tree of descendants scattered across the stars, each with their own destiny. And yet, there is beauty in this vision. Life, which began in the oceans of a single small planet, would have spread to the galaxy itself. Consciousness would flicker under alien suns, on worlds unimaginably different from Earth. The cosmos would no longer be silent, would hum with the voices of our children, carrying forward dreams older than the stars themselves. To imagine such a future is to glimpse the scale of possibility. It may not happen in our lifetimes or even in our civilization's first few millennia, but the universe is vast and time is long. If humanity endures, there is no reason to think we must remain confined to one small corner of the cosmos. The journey will be slow, uncertain, and filled with challenges. But the stars wait patiently. If humanity someday spreads among the stars, the question shifts from, can we survive? To what kind of legacy will we leave behind? It is not enough to imagine distant colonies or vast machines orbiting alien suns. We must ask, what will all of this mean, both for us and for the cosmos itself? The first layer of legacy is survival itself. If humanity endures beyond Earth, it will have achieved what countless species before us have not. More than 99% of all species that have ever lived are now extinct. Dinosaurs ruled the planet for 160 million years, only to vanish in an instant. If humanity builds a civilization that can survive planetary disasters, stellar changes, and even the eventual death of the sun, then we will have carried life itself further than nature alone ever could. In this sense, humanity's cosmic legacy is not only about us, but about every form of life on Earth that has shaped us and shares our journey. But there is a deeper layer. Survival is only the beginning. The true measure of a galactic civilization may be the values it carries outward. Will humanity export its divisions, its greed, and its conflicts into the stars? Or will the act of expansion force us to grow wiser, to embrace cooperation and foresight on a scale never before seen? The cosmos is indifferent to our morality, but our descendants will live within the consequences of the choices we make today. One possibility is that humanity becomes the first conscious species to seed intelligence across the galaxy. If the universe is silent, if we are indeed alone, then every decision we make echoes louder. A lonely galaxy means we are not just one among many, but perhaps the only torchbearers of thought and creativity in a vast, otherwise mindless sea of stars. The weight of that responsibility is immense. To fail would be to extinguish meaning in a universe that may otherwise never know it. On the other hand, if we are not alone, then our future is shaped not only by what we do, but by how we relate to others. Contact with other civilizations, should it occur, may force humanity to re-examine everything it believes about itself. The shock of discovering that we are neither unique nor central could be destabilizing, but it could also be liberating. We may find kinship in the stars, or rivals, or teachers, or even threats. How we respond will define our place in a cosmic community, even if other intelligences exist. They may be rare and fragile, just like us. This makes the idea of cosmic stewardship deeply significant. A civilization advanced enough to shape galaxies must also ask, do we have a responsibility to protect life wherever we find it? If we encounter a young world filled with emerging organisms, do we preserve it as it is or use it for our own needs? The ethics of interstellar expansion may be the most challenging debates of the far future technological possibilities. Complicate this further. Imagine a future where humanity has not only expanded physically, but digitally. Minds copied and shared across light years, consciousness woven into networks spanning thousands of stars. In such a world, the very definition of human blurs. We may become something beyond biology distributed. Intelligences that think and evolve faster than natural evolution ever could. Our legacy then becomes not a matter of survival in the traditional sense, but of transformation. The galaxy would not just host our bodies, but our ideas, our art, our dreams, encoded in forms that endure for millions of years. And then, inevitably, there is the question of time. Even stars do not last forever. Our sun will die in about 5 billion years. Entire galaxies evolve, collide, and fade. On timescales of trillions of years, even starlight will dim, leaving a cold, dark cosmos. If humanity persists, its descendants will face challenges so immense they are almost beyond comprehension. Harvesting energy from black holes, navigating the death of galaxies, perhaps even attempting to influence the structure of the universe itself. These are not just technical questions, but existential ones, in the end. The legacy of humanity in the cosmos may not be about dominance or survival alone, but about continuity. To carry life, intelligence, and meaning into the farthest reaches of time is to give the universe something it otherwise might never have: awareness of itself. We are, as Carl Sagan once said, the cosmos trying to know itself. If that awareness can endure, it can stretch across the stars and through the ages, then humanity will have fulfilled a role far greater than it ever imagined, perhaps. Billions of years from now, long after Earth itself is gone, there will be beings descendants of us, or something that grew from us, who look back and remember that once, on a small blue planet orbiting an ordinary star, humanity began its journey. They will remember our struggles, our dreams, our first faltering steps into the void. And they will carry those memories forward, like embers against the dark, ensuring that we were not just a fleeting accident of nature, but part of something enduring and magnificent. The future of humanity in the cosmos is, above all, an invitation. It invites us to see ourselves not as isolated individuals or even as citizens of a single planet, but as participants in a story that stretches across stars and ages. It invites us to dream bigger, act wiser, and prepare not just for tomorrow, but for eternity. The universe will not wait for us, but it will welcome us if we choose to reach for it. When we pause and reflect on the vastness of the universe, the question of whether humanity is alone becomes more than just a scientific mystery, transforms into a philosophical and spiritual meditation. It is not only about statistics or the probability of planets and civilizations. It is about meaning, purpose, and how we, as a species, define our place in the cosmos. To imagine that we are alone is to imagine that consciousness, as we know it, is an extraordinary singularity. Life may be scattered, perhaps in microbial form, but the capacity for reflection, creativity, and moral reasoning could be unique to Earth. That possibility is both exhilarating and terrifying. On one hand, it means that we are the pinnacle of cosmic evolution, the universe's only chance to know itself. On the other hand, it suggests that we are incredibly fragile, one accident away from extinguishing that rare flame of awareness. Philosophers have long wrestled with the tension between human significance and insignificance. From one perspective, the universe is so vast that human life seems trivial. Our entire history is but a blink of an eye in cosmic time, and Earth is a speck compared to the scale of galaxies. Yet from another perspective, the very fact that consciousness exists at all imbues the universe with meaning. Without beings capable of awareness, the cosmos would be silent, indifferent, and unobserved. With us, there is perception, beauty, curiosity, and storytelling. Perhaps meaning is not found out there, but in the act of asking the questions. Spiritual traditions have long framed humanity's role in cosmic terms. Many religions place humans at the center of creation, chosen or blessed with unique responsibilities. Others describe existence as part of a vast cycle where life and consciousness are expressions of a greater whole. Even outside of religion, people often sense an ineffable connection between the human mind and the stars above. The night sky has always evoked wonder, humility, and awe, encouraging us to look beyond ourselves. If we are truly alone, then perhaps that solitude is not a curse, but a calling. It may mean that humanity has a duty not only to survive, but to preserve and expand the universe's potential for meaning. Every poem, every discovery, every act of kindness becomes more precious because it may be the only instance of such things in all of existence. In this light, solitude magnifies responsibility. We are stewards of consciousness, caretakers of life's one known spark. But solitude also raises deep existential questions. What if the universe has no purpose beyond physical processes? What if intelligence arose by chance, and we are merely a temporary anomaly? Some find this conclusion bleak, but others see it as liberating. If there is no predetermined purpose, then humanity is free to create its own. We become authors of meaning, shaping destiny not through divine mandate, but through choice. This search for meaning is not only abstract. It influences how societies function, how people treat one another, and how we confront challenges. A civilization that views itself as alone in the cosmos may prioritize unity, recognizing that every human life is part of a fragile, irreplaceable whole. Or it may fall into despair, seeing no reason to endure. The philosophical implications are not idle speculation. They ripple through culture, ethics, and politics. Art, too, reflects this tension. From the cave paintings of early humans to modern science fiction films, humanity has always projected its hopes and fears onto the cosmos. We imagine gods in the heavens, alien civilizations beyond the stars, or apocalyptic endings that wipe us away. These stories are not only entertainment, they are meditations on solitude and belonging. They allow us to process the immensity of existence in forms we can grasp. Perhaps the most striking aspect of cosmic solitude is its paradox. The more we learn about the universe, the more alone we seem. Billions of galaxies, trillions of stars, countless planets, and yet no sign of others. The silence deepens even as the scale expands. And yet, in that silence, humanity has found inspiration. Instead of surrendering to despair, we have built telescopes, launched probes, and written songs about the stars. Solitude does not stop us from seeking, it compels us to seek more deeply. In the end, the meaning of cosmic solitude may not be found in definitive answers, but in the questions themselves. The act of wondering whether we are alone, of gazing upward with awe and humility, may be one of humanity's greatest spiritual achievements. Even if we never find others, we have found ourselves creatures capable of reflection, striving to understand the infinite. If the universe is silent, then we are its voice. If it is empty, then we are its meaning. And if we are alone, then our task is clear: to make that solitude beautiful, purposeful, and filled with light. For all the vastness of the cosmos, for all the billions upon billions of stars, and the uncountable worlds circling them, we find ourselves confronted by a haunting contradiction: the Fermi Paradox. It is, at its core, a simple but devastating question. Given the high probability that life could arise elsewhere, and the immense age of the universe, Why do we not see clear, undeniable evidence of extraterrestrial civilizations? Why is the night sky not filled with signals, spacecraft, or cosmic megastructures? Why, in other words, is the universe so silent? This paradox takes its name from physicist Enrico Fermi, who, during a lunchtime conversation in 1950, famously asked, "Where is everybody?" His colleagues had been discussing the likelihood of advanced civilizations in the galaxy, and the apparent contradiction between the estimated number of habitable worlds and the complete lack of observable visitors or communications. The question was not just idle curiosity cut straight to the heart of our understanding of life, its intelligence, and cosmic destiny. The universe is roughly 13.8 billion years old. Our galaxy alone is about 100,000 light-years across and contains some 200 to 400 billion stars. Based on current astronomical surveys, it is now accepted that most of those stars likely have planets. Many of these planets lie within what we call the habitable zone, the range, where conditions might allow liquid water to exist. With such staggering numbers, it seems almost inevitable that life should arise somewhere else, and given enough time, evolve intelligence. And yet, when we look outward through the powerful eyes of radio telescopes, deep space observatories, and interstellar probes, we find nothing. No alien signals. No interstellar spacecraft. No Dyson spheres devouring the light of their stars. Just silence. This silence is unsettling because it suggests one of two possibilities. The first is that we are truly alone, that Earth is unique, not just in our galaxy, but perhaps in the entire universe. The second is even more troubling, that intelligent civilizations do exist, but something prevents them from reaching out, expanding, or surviving long enough to be noticed. Both scenarios force us to re-examine not only our expectations about life, but also our own future as a species. The paradox is sharpened by the fact that if a single advanced civilization had arisen in the Milky Way even a few 100 million years ago, it could have spread across the galaxy by now. Space colonization, even at relatively slow speeds, could allow a civilization to visit or at least leave evidence on every star system within tens of millions of years. Compared to the age of the galaxy, this is the blink of an eye. And yet, no such evidence exists. This absence has led to a wide variety of proposed solutions, each offering a different vision of the cosmos. Some are hopeful, suggesting that civilizations are rare but possible, and that we may simply be among the first. Others are dark, hinting at universal catastrophes, self-destruction, or predatory forces that erase civilizations before they can expand. Before diving into these explanations, it's important to recognize that the Fermi Paradox is not just a scientific riddle. It is also a philosophical mirror, reflecting our deepest fears and hopes about the nature of life and our own place in the cosmos. When we ask, "Where is everybody?" we are also asking, what does the universe allow us to become? The paradox forces us to wrestle with uncomfortable questions. If we are alone, does that place upon us a cosmic responsibility to preserve and spread life as the sole representatives of consciousness in the universe? If we are not alone, why has no one revealed themselves to us? Are they indifferent, hiding, or gone? And most chilling of all, if other civilizations existed before us, what happened to them, and could the same fate await us? This is the essence of the Great Silence. It is not merely the absence of sound in the void of space, it is the absence of confirmation, of contact, of companionship in the cosmos. And it is this silence that transforms the night sky into both a source of wonder and a source of dread. As we move deeper into this paradox, we will explore the possible solutions ranging from the optimistic to the apocalyptic. Each carries profound implications for humanity's future. Each is, in its own way, a story about what it means to exist in a universe that seems vast enough for countless civilizations, yet quiet enough to suggest we may be utterly alone in the end. The Fermi Paradox is less about aliens and more about ourselves. It is a question that demands we think beyond our present, beyond our species, and beyond our world. It asks us to consider the fragile balance between possibility and inevitability, between survival and extinction, between being one of many or being the only one, and as we stand at the dawn of interstellar exploration. It reminds us that perhaps the silence of the universe is not an answer, but an invitation, a challenge for us to listen more deeply, to search more broadly, and to understand more profoundly what it truly means to be alive in a cosmos that so far has given us no reply. As we come to the end of this cosmic journey, it is worth taking a deep breath and letting the immensity of the universe sink in. From the tiniest atoms to the vast clusters of galaxies, the universe stretches across unimaginable distances and unimaginable time. We have asked ourselves profound questions. Are we alone? What would it mean if we truly were? And if we are not alone, what might other civilizations have achieved across the stars? We have explored the age of the universe, nearly 14 billion years, and considered how brief humanity's presence has been in comparison. Life on Earth is but a fleeting spark in cosmic history, yet in that spark exists the power to wonder, to reflect, and to dream. We imagine civilizations rising and falling, the possibility of interstellar voyages, and the ethical responsibilities that come with becoming a species capable of shaping the galaxy itself. The silence of the cosmos, the Fermi Paradox, reminds us that either we are rare, alone, or simply not yet ready to detect others. Each possibility carries weight, responsibility, and reflection. If we are alone, then the universe has entrusted us with consciousness itself. If we are not, then the universe may be richer, stranger, and more mysterious than we could ever imagine. We considered both the scientific and philosophical dimensions of our solitude. The very act of asking these questions connects us to the cosmos in a deeply human way. It is in our curiosity, our exploration, and our imagination that meaning is born. Even if the stars remain silent, our awareness, the stories we tell, the knowledge we pursue, gives light to the darkness. Perhaps one day, our descendants will traverse the stars, building civilizations among alien suns, expanding life and consciousness beyond Earth. Or perhaps we will find other civilizations, teaching us lessons we cannot yet conceive. Regardless of the answers, the journey of inquiry, the wonder of exploration, and the humility in facing the vast unknown will continue to shape us. Thank you for joining this voyage through time, space, and thought. If you have questions about the origins of the universe, the Big Bang, or the nature of reality itself, you may also enjoy watching our other video that delves into those mysteries. Until then, remember that whether we are alone or not, our place in the cosmos is precious, and the act of contemplating it is a journey worth taking.